All right, let me just double check to make sure that everything's doing what it's supposed to be doing, and it is. Okay, so now we can go ahead and officially get started with this bad boy. I apologize for the delay. As I mentioned earlier, man, this new update to the software that I'm using is killing me. It's killing me. Every step of the way, it seems to be producing some really uncomfortable bugs that have stopped the production. And so let's go ahead and just get started today. So how'd you guys do on your game dice? Good? Is it all right? Everyone had fun? Kind of get back in the swing of things, shaking off the cobwebs, removing the rust, getting back into the process of 3D modeling again? Yeah, good, good. And so today we're going to continue our conversation and really jump into our first big conversation about UV mapping. Every single one of us in here are now forced to work inside of the UV mapping production pipeline. It's no longer an option for us. Now, if you think about it, if we go way back into the time machine and talk about how we created texture maps for GCOM 402, we used a process called projection mapping, right? Does anyone remember that big concept, that big idea in the sky that is projection mapping? What is that all about? Anyone? Anyone? Bueller? So here's my little, let me kind of illustrate. Here's a little cylinder, and I'm going to projection map a texture onto this bad boy, okay? It's going to be pretty easy, and I'm sure you guys remember this. When we're applying materials, or excuse me, when we're applying texture maps to any sort of objects inside of Modo, what's the first thing that we should do? Before we even do that, what's the first thing that we got to do? Before we even do that, all I have here is a hunk of geometry, okay? I'm ready to put a texture map on it. Brian, hit me. Set a material, absolutely. We have to isolate this object from the rest of the scene by setting a material, okay? Now help me out. How do I create a material for my little cylinder here? Select it and then do what? And the M key. Let's just do it. Select it. Hit the M key. You're going to get this great little dialog. This is polygon set material. Are we allowed to ever use the default material? No. Okay, we need to give it a name. Be as specific as you can. I think for me, I'm just going to call this cylinder. And now, let's go to the shader tree and continue doing the lion's share of the work. If you were to zoom in and check out the shader tree, you can already see, let me just do it real fast for you guys. You can already see that we're starting to establish our shader network over in our shader tree. We've isolated those polygons in their own material. So anything that I do to that cylinder material is going to only influence the cylinder within my three-dimensional scene. And of course, if I expand it, we can actually start to focus on the material, the fundamental material for this object. In every sense, what kind of function does that first item in our hierarchy serve? The one with the green and the red dot. What's that like? Yeah, it's a group, it's a locator. In my mind, it's kind of like a folder, right? All the things that we want to apply to this series of polygons needs to be inside of that folder, right? And only the polygons that are associated with that folder are going to be influenced by the objects inside of that folder, right? So I think of it like a gigantic folder that has a direct relationship to a series of polygons within our three-dimensional scene. All right, so let's get something in here, and I think I'm just going to go. I'm just going to do something really easy here, and with my group selected, my folder selected, I'm going to go Add Layer. And let's just do some Emoto stuff, some procedurals, and I'll just do some I don't know, some dented noise. There we go. And let's jump over into the render tab and take a look at what that looks like. You know what may be better for this, and I apologize. I'm going to take a step back. Instead of doing dented noise, I'm going to do. Let me delete that. And I'm going to do, let's see here, I'm going to do just a grid. That way we can see, that way we can see the quality of our projection at play here. Okay, so we are projection mapping this bad boy onto our object, okay? The texture locator is assigned to every sort of image map that's applied to any of our material groups, right? The texture locator is the most important element inside of our shader network. Because in addition to having a relationship with the object, what is the texture locator's sole responsibility? What does it do? You got it. It's going to determine the placement of the texture along the polygons that are associated with that material. Okay, so think placement, placement, placement. Okay, and specifically, we're looking at the transform of this texture, right? We get to determine its position within the three-dimensional scene, its rotation, and its scale. All things that we have ultimate control over when using projection-mapped textures. Okay. Now, if you remember way back in 402, projection mapping yields us a number of different projection types. These projection types are nothing more than a series of rules. And as you can see here, I am using a grid texture, and I'm kind of blasting this texture onto the surface of my geometry. You guys remember the metaphor that I used in 402 to kind of describe in the bigger picture of things what texture mapping is truly kind of doing, the function of it? Does anyone remember it? Okay, it's kind of like a cinema projector, right? If you think about it, next time we go to the movies, there's a gigantic projector in the back of the auditorium, right? And its sole purpose is to blast a two-dimensional image onto a gigantic screen, right? Well, we're fundamentally doing the exact same thing. Our texture locator, in every sense, is like the projector, that cinema projector in the back of the movie theater. And it's blasting an image not on a screen, a two-dimensional screen, but a three-dimensional polygonal object, okay? So we're just taking a two-dimensional image and we're blasting it at a three-dimensional surface, okay? Now the method that it kind of blasts and projects this image onto the surface of our three-dimensional model is determined by the projection type. And there's a whole series of them, okay? If you cruise over to your texture locator tab on the right-hand side of the screen, here it is. Here's the texture or the projection type pull-down menu. And you can see there's a whole bunch of them, okay? You have solid, planar, cylindrical, spherical, cubic. Do you guys remember working with this in 402? Starting to come back a little bit. Yeah, we did a lot of projection mapping in 402, okay? It allows us to very quickly get an image on our polygons. Now, ultimately, what we want to try to do is match the projection type with the basic shape of the 3D model that we're projecting it onto, right? What's the basic shape of the 3D model I'm using? It's a cylinder, right? So which of those projection types makes the most sense? Cylindrical. Yeah, you got it. So let's just do it real fast, and let's compare and contrast the results. So there it is with here's my object with a projection type of solid, and we have some big issues here, okay? Yeah, some nice stretching. You know, it's definitely not so much a grid on the top. It's basically projecting the image down the x-axis. However, let's change it to cylindrical and see the result that we get. Now, I know what you're saying. You're saying, whoa, Pat, we've taken a step back. This is even worse. And I would say, yep, you're absolutely right. This is worse. However, we're now closer to the end result than we were before. All of our projection types are going to require us to go in and tweak things, right? There's never a silver bullet. There's never an easy way. There's always some sort of human interaction that's required to get our textures to show up the right way. 9 times out of 10, the element that fixes our problem is the projection axis. And let me just kind of zoom in real quick over here. So we can take a gander. There it is. Ta-da! Projection axis. Right now, we're projecting our texture down the x-axis. Now, which probably axis makes the most sense here? The y. Why? Why the y-axis? Why? Ask why. Why? Why? Because it's vertical. Our cylindrical is oriented along the y-axis. So let's give it a go. I always experiment with this whenever I'm doing any sort of projection mapping, because changing the projection axis is going to drastically change how our image is being shown up on our mesh. So let's just do it real fast. There's the y, and hey, ho, now we're getting there, right? Now we're getting something that looks a little bit more like what we're supposed to look like, but it's still not a grid. So now that we've zeroed in on the correct axis of projection for this texture along our three-dimensional mesh, what's the other thing that we got to worry about? Remember, what's the role of the texture locator? What's it do? What is it responsible for? Projecting, and ultimately the placement of the texture within the scene, so the position of the texture within our three-dimensional scene. One of the three channels that determines the ultimate placement of this texture is the size of this texture, right? Right now we have a fantastically humongous image being blasted on a very tiny cylinder. We need to scale down this texture to match the relative size of our three-dimensional model. And luckily for us, the guys down at Luxology have made this very, very easy to do. The first thing that I always try is hit the auto size button, see what we get, and it looks like it didn't do a single thing. So let's try a different projection axis here. There's X, there's Y, there's Z. Okay, let's go back to Y. And now I think it's time for me to get a little bit more involved in this and manually start scaling this the way it needs to be. And let's see, why am I not seeing what I want to see? I think you are absolutely right. Let's do this. Oops. Along the wrong one. Let's go to the actual texture layer itself. Just make sure everything is copacetic in here. And shoot, the cylindrical projection axis may be giving us the wrong read here. So I'm not going to devote too much extra time to this. However, I think you can begin to see the little bit of the issue that we're working with here. Yeah, planar is not going to do what we want because you can see that it's just blasting it vertically down the y-axis. Solid was mediocre, but at least it was a usable kind of result. Welcome to our hell with projection mapping, okay? It really is a monumental pain in the rear end. I hate projection mapping, in all honesty, because you're forced to go through the song and dance of figuring precisely where this texture locator is blasting this image within, okay? It's not easy, and sometimes it gives you very, very poor results, okay? And it certainly does take a significant amount of time. I bring this last point up because as game artists, we're not even allowed to work with inside this area, right? This is not even an option for us inside the game art production pipeline. What is the only way of projecting an image onto a series of polygons in a game engine? UV mapping, okay? Today starts our exploration, our arduous journey into the uncharted territory of UV mapping. It is going to be daunting, it is going to be scary, it's going to be wicked hard. It's not going to be something that's easy for all of you guys to grasp this week. I mentioned and specifically chose the word journey because in every sense it is a journey, okay? Today is our first kind of foray into an idea that's complex, okay? That's complex, so it's going to be, every single one of us in here has a path that they're walking down when it comes to UV mapping. Game engines only understand UV mapping. It's no longer a choice. In GCOM 402, you had a choice, right? You could use projection mapping and tweak until your heart's content, or you can make a UV map. And now we no longer have that choice. We're forced to work with inside the UV mapping production pipeline. Over the next, 14 weeks now, you guys are going to become ninjas at UV mapping. Okay, you will learn a tremendous amount about this specific facet of the computer art production pipeline, and you'll get good at it. You're going to be god-awful at it today. It's not going to be something that's easy. It's going to be quite difficult, but you're going to get there. Trust me, you are going to get there. Okay, every one of you guys is going to have one of those aha moments over the next 3 or 4 weeks where you go, aha! I understand it now. I get this crazy idea that Pat's been preaching about over the last couple of weeks, okay? So our adventure in UV mapping begins today, and we're going to start rather slowly. Before we get started into the particulars of the technology, let's just begin our day by describing what the expectations are this week. Over in renderography.com, I've already done you guys the service and posted this week's homework and lab assignments. As you would imagine, this week's homework and lab under GCOM 424 are going to focus entirely on the production of UV maps. We're going to be building a small little wine barrel today, and then through this exercise, you'll be able to, again, to revisit your 3D modeling skills and also begin to incorporate UV maps and the accuracy of working with inside of Photoshop. So we actually have a lot of ground that we need to cover today. In that, we need to talk about UV maps and then the bridge between Modo and Photoshop so that we can start creating our textures and then sending them back. Okay? Yes, sir?
The thing that was due today,
Mm-hmm.
due at the end of the day, midnight?
It was due at 1:15.
Okay.
Yeah, 1:15. You have a full week. A full week. So all assignments are due by the beginning of the next class, unless otherwise noted. Okay. So as I mentioned earlier, we're going to be building a little wine barrel. This is going to be a very, very simple little project. We'll go through some of the particulars a little bit later, but you can see from some of the examples that this is the target, this is the goal, this is ultimately what we're after in this week's assignment, is to, bam, pop this bad boy out, or something similar to this, okay? Yeah, it's going to be pretty cool. I would ask you guys to remember that over the next couple of weeks, you're going to be building a whole series of assets in your homework assignments that you then can use again in your final project for this course, okay? So keep that in mind. These are not like throwaway projects, okay? There is a method to my madness. We're building a library of assets that you can use for the rest of the semester, okay? Because if you look around, video games, what's the one thing that you always see in video games?
Palette swaps.
What?
Palette swaps.
Palette swabs?
Swaps.
Swaps? I'm going to pretend I know what that is. I don't know what that is. Help me out, Thomas. What is a palette swap?
Basically, it's the same object, it's just a different color.
Yes. Okay. And specifically, the object's what's most important, right? Because you're always going to see barrels. You're always going to see crates. You always see a dumpster. There's always going to be there's a whole library of props that you always see in video games. Well, we're going to build that library, okay, or begin to build that library. Our lab assignment this week is going to continue to challenge you on the UV mapping side. I've provided this little small scene to you, and your mission during your lab is to make UV maps for all of these elements, and then to apply the basic UV checker preset to those objects, and then to produce a quick render. More on that as we get to it. So every week, we're going to be flexing our UV mapping skills, okay? Every week. We're going to start basic, in the very simplified kind of outline of the technology today, and then we're going to advance over the next couple weeks to do some really neat things, okay? All right, any questions on what we're going to be talking about today? As always, in the resource tab, I've given you guys some love. There's under the important documents heading, we have the project file for our lab. So go ahead and download this if you haven't already. In addition, I've also created a whole series of videos that encapsulate almost the entirety of today's conversation. So if you need a small little review as to what we talk about, those 5 videos are going to get you where you need to be. Okay? All right. Okay. Questions so far? James, do you have a question?
It's not something, it's like, okay, I do have a question, but it's going to detract from the lecture.
Okay, then we'll hit it during the lab then.
Yeah.
Okay. So, UV mapping. What is UV mapping? Was ist das? This is a strange idea. It's a strange concept, is it not? What is it? What is a UV map? Does anyone have any experience with that? Alan, go ahead.
Mapping the surface of something that's not 2D into 3D.
Okay, I like that. I like that. Bear with me just for 2 seconds. I'm going to create a primitive, unit primitive of a cube. Because all good demonstrations of technologies begin and end with a cube. So we're going to start simply by exploring a tube. And I think Alan is in the ballpark as to what a UV map is. A UV map, before we get started, let's kind of define the benefits of a UV map. The benefits of working with a UV map is that we get to accurately place texture information on very specific parts of very specific polygons within our scene. So the computer's we're no longer working with global rules like we were with projection mapping, right? Gone are the days where we had to mess around with projection axes and sizes and positions and all that mumbo jumbo that we were just experiencing inside of the projection mapping world, right? UV mapping is a whole new ball game, okay? It's a crazy ball game. That's a tremendous amount of fun. And ultimately, it allows us to place specific information at specific places within our polygons. And I mean incredibly specific, almost on the per pixel level, okay? So it's a great, great way for us to add detail. If you're really excited about the idea of texture painting or interactive texture painting, you have to have a UV map. If you want to do some sculpting later on, you have to have a UV map. If you want these things to go into a game engine, which we obviously do in the game art class, you have to have a UV map, okay? The game world requires UV maps for every single art asset. We don't get the luxury of projections. UV maps are a universal element. It's one of the few kind of core pieces of technology that we have adopted industry-wide. Every single 3D modeling application is going to understand the role of a UV map and include them in the models when we import them into other apps. So if we were to UV map this little cube here, send it over to Maya, that information will follow the geometry, okay? In every sense, what we're doing when we create UV mapping, or when we're creating a UV map, is creating a 2D version of our three-dimensional model. Let me show you a really great illustration of the power of UV maps before we go a little bit further. I have some project files on my computer here, and let me just go snag some. Let me open up this little crate. This is something that you will see momentarily, okay, in the next couple of weeks. Cool little crate. Every project has crates, right? Very, very simple, very, very basic. You're going to be doing this, I think, next week, if memory serves, okay? But what if I wanted to place a very specific decal, like on the top of the crate? How would I do that? You can't do it with projection mapping, right? The only way for us to place specific texture information is to generate a UV map. And I apologize, I think I may have opened up the incorrect version of this. No, I grabbed the right one. For whatever reason, none of my textures got... Ah, there's the textures. Aha, there we go. So this is kind of the accuracy that you get, okay? We can go in and very, very quickly add fine detail and place that detail precisely where we want them to go, okay? We're not working generally with these global tools like we were in the projection mapping stage, okay? This is accuracy. This is getting specific as to where specific texture information is going to be placed on our objects, okay? So this is the benefit. You're not going to be able to do this level of texture detailing without UV maps, okay? All right. You're going to love and hate making UV maps, okay? UV maps, you know, are a blessing and a curse, because on one hand, you know, they allow us to do some really cool things and to place images precisely where we want them to be, but they're also a pain in the rear end to make. They really are. Oh my gosh. There's nothing more laborious than making UV maps, okay? Luckily for us, the guys down at Luxology, they know this, okay? They know that a major bottleneck in the entire production pipeline of 3D models are UV maps, okay? So they've made some really great tools for us, some really great tools that expedite the entire process. You're lucky in a sense that you're making models in Modo, because we got it good. We got some of the best UV mapping tools in the business. If you're coming from other 3D modeling applications, you don't have it as well as we have it here, okay? For example, at the end of class today, I want to show you how to export your UV maps. It's great. In Modo, it's a one-click process, right? It's phenomenal. In other apps, it's crazy. What you have to do in other apps to get your UV map out is to make the image as large, to make that window as large as you can, and hit the print screen button to take a screen capture of your UV maps. What? That's just stupid, right? It's crazy. So we got it good here. We got it good. I know, right? People are like, "Are you serious?" Yeah, I'm serious. I'm serious. Okay, let's jump in and talk about how we can build our UV maps. And I'm going to go back to my untextured cubes. Believe it or not, every unit primitive that you create inside of Modo automatically is generated with a UV map, except they're horrible UV maps. They really, really are, okay? We're going to be spending the entirety of our day in the UV layout, which is this tab way up here at the top of our screen. It's a little bit different. They've brought to the surface all of our UV mapping tools, and as you can see, they have changed the interface to highlight some very important workflows, okay? as with anything inside of Modo, you're going to find all of your tools over here. So these are all of our UV mapping tools. They are duplicated in other areas within the application, but they're all exposed here, which is kind of nice. Okay. Our OpenGL viewport is broken up into two very unique environments. This guy over here, we'll talk about this one a lot. This is where we're going to be doing a lion's share of our work. Okay. This is our UV grid. More on that in a minute. And of course, its neighbor to the right is just a standard OpenGL viewport. Okay, nothing too fancy. Also, in 701, they've slightly changed what pops up on screen when you click on the UV tab. They're going to bring the shader tree to the surface, which is fine. But please remember, you still have access to your item list, which is also really important. Okay. All right. So what are we doing here when we make UV maps? Now, if you have, there we go. There's my UV map. Okay. If you have something like this on your screen, congratulations, you're looking at a UV map. When you're working with unit primitives, Modo is going to try to make a UV map for you automatically in the background of the application, yet it does a horrible, horrible job. It's really kind of amazing how bad of a job it actually does. Okay? So we're going to delete 90%, 99% of the UV maps that Modo is going to auto-generate for us. Okay? So let's just go ahead and do that so we can start working from a clear palette. Now, if you don't see anything like this, if you're following along, let me kind of draw focus to how we get access to all of our UV maps. In the same row of tabs that you would normally find your Properties tab, if we keep cruising down, we have a tab called Lists. When we click on that, the top part of our interface here is going to draw focus to all of the important data lists and vertex maps and subdivision weight maps and all this other phenomenally cool, fun stuff in this area. So this is where we get access to all of our UV maps in this list. Okay, I've expanded my UV map section, and you can see that Modo automatically generated one for me called Texture. Let's rename that, shall we? Because I hate just having it called Texture. I think that's just kind of like makes me feel rather uncomfortable when something is ambiguously named like that, right? So let's give it a new name. How would you imagine you would change the name of your UV maps? Yeah, just do a click pause and then click on that name again. You can change the field. In addition, you can also right-click on your UV map. You can right-click on it. You'll get a small little contextual menu that has some very obvious commands within it. Of course, rename is also in that. Let's just do it real fast. Of course, when you hit rename, there's a pop-up that comes up. And let's just call this box. All right, so now I got my box. And I need to get rid of all of these UV tiles, but we'll do that here in a minute. Let's start defining what a UV map is. Okay, I want to change a couple things in my OpenGL viewport to make it a little bit easier for you guys to see what's going on. Okay, so what are we working with here? What is a UV map? As I mentioned earlier, it's a 2D representation of a three-dimensional object. This is the 2D version over here. The little white outlines, that's the 2D version. This is the 3D version, okay? If you take a step back and look kind of theoretically at what we're doing here, we're kind of like making a pattern of our cube. Now, every single one of us in here, I think, is wearing an article of clothing, if my eyes don't deceive me. You're like, no, I'm not wearing anything. This is just, I've spray painted my body to make it look like a hoodie. In order for us to make these shirts, right, we have to start off with a pattern of that, for the fabric, right? All articles of clothing begin with a two-dimensional pattern, right? Because last time I checked, when you're cutting fabric, fabric is very much a two-dimensional plane, right? We have to transform those two-dimensional pieces of fabric into a three-dimensional volume that I can put my body within, right? So everything in the clothing world starts as 2D. We start with a pattern, and then either a machine or a seamstress is going to cut that pattern very closely, or cut the fabric very closely to the pattern, and we'll get the outlines for that article of clothing. We're kind of doing the exact same thing. We're making a two-dimensional pattern for our three-dimensional cube. Except we're kind of doing it in reverse, right? We don't start with the pattern like they do in the clothing world. We start with the final object, and we kind of have to reverse engineer it into a two-dimensional shape. Another way of thinking of this, maybe it's like a birthday present. Okay, it's like a birthday present. In your mind's eye, it's your birthday. Happy birthday! Happy birthday. Okay. And you have a present sitting in front of you, a wrapped present with a little bow on it. Gotta have a little bow. It's so much better when there's a little bow. Makes it feel festive and fun, right? Otherwise, it's just a box, right? With a bow, now it's a present. So you have that wrapped birthday present in front of you, okay? Maybe instead of there being a lovely colorful pattern on the exterior of our wrapped birthday present, it's just all white. It's just white paper, or like brown, brown paper bag paper, right? That brown butcher block paper, okay? I want to paint on that wrapping paper. I want to be able to go and draw my own designs on there, right? In order for me to draw my own designs on our wrapping paper, I have to very carefully peel the tape back, okay? Very carefully take that wrapping paper and unfold that wrapping paper until it lies so that it lies flat on my table. Then I can take my paintbrush and go crazy with it. I can paint all over it. I can put, like happy birthday pad on it. That'd be kind of fun. Maybe a big smiley face. Dinosaur, because I like dinosaurs. Of course, there has to be the obligatory Star Wars character, because I'm a big Star Wars nerd. Okay, but we have to make sure it's lying flat first before we can paint on it. We're doing the exact same thing. We're starting with a finished birthday present over here on the right. Okay, we're very carefully going to peel back all the little chunks of tape and lie it flat on the ground so we can paint on it. That's what we're after. We're starting with a really basic example here with the cube, but if you take this to the nth degree and look at some more complex examples, and we'll do that a little bit later, it turns into a little bit of a nightmare. Okay, it can get very complex very quickly. But there are some important ideas, some foundation level thinking that we need to kind of instill in our core to make this entire process go a whole lot easier. Okay. UV mapping requires a significant amount of discipline, okay? This is not one of those things that you can just kind of stumble through. If you get the order of operation incomplete, you're not going to get a good result. If you are hapless and careless, you're not going to get a good result, okay? Remember, this wrapping paper is going to define the quality of the texture that we're going to be able to paint on it. So if our UV maps look like crap, well, our textures are going to look like crap too, okay? We're making a coloring book for our object, okay? The quality of the lines within that coloring book is going to determine the quality of the texture that will ultimately get placed on side of that thing, okay? So this is one of those things where it's like with great power comes great responsibility. We have to remember that, that what we create on the UV map is going to have a direct, not an indirect, a direct impact on how this object is going to adopt its textures. Okay? All right, let's go ahead and get started and do it. Let's take a look at what some of these the components of our UV maps are. Okay? I mentioned earlier that our UV grid is going to be a critical important area for us to work within inside of the UV mapping layout. We're working with a grid, and let me actually zoom the grid out a little bit so you can get a better idea of what the workspace looks like. Okay, you can actually zoom in and out using your standard keyboard shortcuts as far or close as you want. But this is it. This is what the environment looks like. We're going to be doing the lion's share of our UV mapping editing and creation inside of this grid. This is a new custom workspace. We're no longer working along the X and the Y axis, okay? We are working along the U and the V axis, which is a custom work environment just for textures, okay? Just for textures. So the ideas, the concepts between the polygonal workspace are very, very similar. We are still working along a two-dimensional grid. Okay, this is the U axis. And we'll pretend that's a U. That's a really bad U. And this is the V. Okay. As you can see, we'll go back into like high school geometry, right? 10th grade geometry. You spent a lot of time plotting points along a 2D Cartesian grid, not too dissimilar from this. Okay. your grids, or excuse me, your, all of your grids were broken up into 4 quadrants, right? Where is the center of our quadrants, the center of our grid? Everything has a center point, right? We have the origin of our scene in our OpenGL viewport. We also have to have a center point, or the origin of our UV mapping workspace, right? Where is it? 0, 0, but visually, where is it? I'm a visual guy. Where is it? In the middle, right? At the intersection of both of our axes. So in every sense, what I'm talking about is whoop, right there, okay? That's the origin. That's the center point of our grid. Now, we have 4 quadrants that we have to work within, okay? The most important, what I'm talking about quadrants, are these guys, okay? So I got like quadrant 1, quadrant 2, 3, and then, of course, quadrant 4, okay? One of these is more important than the other. As you can kind of see from the automatically generated UV map that Modo made for us, quadrant 2 is the most important one. All of our UV islands, those little white, ghosty cube things, squares, are going to show up in quadrant 2. Why? Because that's just where it is, right? No, there's a method to the madness, right? I am not a subscriber that computers are these magical things, right? They are made by humans. If we understand the thought process, it's not as mysterious, right? It's a whole lot easier to... Bingo! Alan's got it right. Perfect, perfect, perfect. This is the only quadrant within inside of our grid where the U and V values are positive, okay? So, of course, the V axis is the vertical one, and the U axis is the horizontal one. This is the only axis where these numbers are positive and these numbers are positive. In quadrant 1, we have, positive V, but we have negative U. This is, or actually maybe I should be doing UV. So we get negative, negative over here, and then U positive and V negative in quadrant 4, okay? So quadrant number 2 is the only place where we have positive values for both the U and the V axis. This is the home, okay? These are where all of our UV islands are going to go initially. They can live in other parts of the scene, as you will see here in about 6 weeks when we start talking about tiling textures. But for us today, we want all of our UV islands to be squished, to be placed, if you will, inside of that positive UV quadrant, okay? So start programming your brain to look there, upper right-hand corner of our grid. That's where all of our UV islands, as they're called, need to go. Okay? Only place where we've got positive values on both the 2 axes. Okay. Let's go in and take a look at what these things are. Okay? These are called UV islands. UV islands, the little white, ghosty white cubes in the center of my quadrant. They don't represent a UV map, okay? Think of like a UV map, like a treasure map, right? And then on the inside of that treasure map, there's a whole bunch of little icons, right? So hopefully a little squiggly line. Hopefully like a little X with a circle around it saying the treasure's here. That'd make it easy, right? That was a bad joke. It was funnier in my mind, okay? So we're working within a UV map, and then on the interior of our UV map, we have these UV islands. In the Modo, they're these light, kind of, semi-transparent cubes, okay, or semi-transparent shapes. They might not necessarily be cubes going forward, but they're going to be semi-transparent shapes, okay? These aren't magical, okay? What these are nothing more than a 2D version of our 3-dimensional polygon. Let me illustrate this. I'm sure a lot of you guys, if you're following along, have already started to notice that when I hover over any one of these UV islands, its corresponding 3-dimensional friend on the right there automatically gets the exact same highlight. And if I was to select one of my UV islands on the left, its corresponding 3D friend would also get selected. They're the exact same thing. They're the exact same thing. We have a 2-dimensional version and then a 3-dimensional version. Okay? We have the wrapping paper lying flat over here on the left, and then we get the wrapped object on the right. Okay? So if I select any number of these, I can go ahead and select them. You can see their three-dimensional counterpart is automatically selected in our OpenGL viewport. Okay. Some of the same selection systems apply. If I double-click on our UV island, all the contiguous UVs will be selected, and their three-dimensional counterparts will also be selected. So in every sense, it's a great way for us to very quickly select complex shapes, right? Because we're not having to go into our OpenGL viewport and like click, 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 click. We can just double-click on our UV island, select things quickly. It's a great selection system. In addition, we can also move our UVs. We don't really want to historically move them away from the center of our UV grid, but we can use the Move tool and manipulate their location within inside our UV grid. Now, what wasn't happening to my 3D friend over there on the right when I was moving the UVs? Yeah. It was not moving. Absolutely. The only thing, well, there's two things that share, that will influence both the UV grid and the OpenGL viewport. Selections, that's one thing that will influence both areas, and deletion. Everything else is separate, separate, separate. Okay? I can move my UVs, my object's not going to move. Okay? I can rotate my UVs, my object's not going to rotate. Okay? So they are kind of different work areas. However, the one element, as I mentioned before, is deletion. I have my UVs selected, and if I was to hit the delete key, oops, now my cube's gone. Okay? There's a relationship between the polygons on our UV island and our polygons in our map, or in our scene. Hitting the delete key or the backspace key is going to delete both of them.
Okay, my new roommate has to pick up the key.
Uh-huh.
What time are we taking a break?
I have no idea, but I would imagine it's going to be within the next hour. Okay. All right. So the question kind of comes up: how do I delete my UVs without deleting my cube? Right? How do I do that? I've shown you one way already. That's the other way. What was the first way that I showed you? Go back to that list. Right-click on your UV map in your list, the one that says box. Aha! Aha! So there's a couple choices in this contextual menu that are important. Of course, we had the delete. What's going to happen if I was to hit delete? What's going to delete? Just the UVs? Let's take a look. If I was to choose delete from this menu, the UVs are going to get deleted, but more importantly, the treasure map that they're residing within is also going to get deleted. Are you sure? Yep, I'm sure. Boom. Notice that my box UV map in the lists is now gone, as are all of my UVs. So hitting the delete button on that right-click menu is going to delete everything. Okay? What if I just want to delete the UV islands? I want to keep the map, but I want to delete the islands. Let's go back in time for a second. You don't have to necessarily select them individually. In that same right-click contextual menu that we were just in, let me zoom in so you guys can see what's happening. Right-click on it. There's clear. Okay? This is going to delete everything, or all the UV islands within inside of our map. It's going to keep the map, but delete the islands within it. So if we hit clear, box is going to stay there. That's still there. But if you look at our UV grid, oh, our UV islands are gone. Okay? So that's an easy way. That's one way. Alan, you had another way. What was it? Okay, so I got mine selected. Then what? Edit UVs over here in our toolbar. Okay? So edit UVs from within this list. We actually have a couple values. Delete UVs is one of those values. Okay? So that's kind of neat. Delete UVs. Hit it right there. Also, at the top of the screen, I want to draw your attention towards the texture pull-down menu. We're going to be spending a lot of time in here over the next couple of weeks. There's some really neat things in here that we want to focus on. We have a UV operators series of tools. Delete's right at the top. Okay? So 3 different ways to delete UVs, either in the right-click contextual menu on the list, in the UV editing tools on the left, or from the UV operators series of tools at the top. Right-click on the UV island itself. Yeah, you know, it's not something I normally do, but let's check it out. So you right-click on it, right-click, and deletes there as well. Good find, Aaron. Good find. Good times. All right. So I want to delete mine, or before I delete mine, excuse me, I got a little ahead of myself. I want to show you something. Okay. We have a little bit, kind of, some working knowledge of what a UV is and their benefits within inside the larger production pipeline. However, there are some really big ideas that we need to honor as we generate our UVs. Rewind for a couple seconds to the beginning of this conversation. I said that Modo is automatically going to make UVs for us, right? You can see them here. They do a horrible job, horrible job, because the guys down at Luxology have ignored probably the most important ideas about UV mapping, okay? The foundation of the technique that we're going to be exploring is kind of built upon this idea. The size, scale, and proportion of our three-dimensional object needs to be identical to the size, scale, and proportion of our two-dimensional guy, okay? So our three-dimensional polygons need to look the same over here. The size, scale, and proportion needs to be identical to get the correct illusion that we're after, okay? Now, look at the polygons on the left, okay, the UV islands, and compare them to their three-dimensional counterpart. Do they look the same? No, they don't, right? We're working with a unit primitive on the right. Define to me from GCOM 402 what a unit primitive is. Yeah, Elijah.
The exact same size in every direction.
You got it. So we know from just by that definition that all 6 sides of our cube are what? The same size. They're identical, right? They're squares. Do we have squares on the right? What do we have on the left? Excuse me. Rectangles. Rectangles. This is bad. This is horrible. We don't want rectangles, okay? We have to have squares, okay? Now, there's a reason for this, and let me show you what that reason is. We need to make sure that all of our objects match the size, scale, and proportions of their three-dimensional friend. Let me show you why. I'm going to throw this cube into its own material like we did before with the cylinder, and I'm just going to call it cube. Oops, cube does not begin with X. There we go. There it is. Let's go over to our shader tree, and I can get rid of cylinder. I don't need that. Excuse me while I do some housekeeping. So there's cube. Okay. Notice that I have the group selected. Okay, the material group is selected right now, not the actual material. The folder is selected. Because I'm going to use a preset, and I want the contents of that preset to automatically be applied to that folder. Okay. When we're UV mapping, it's the easiest way for us to check, to confirm beyond any reasonable doubt if we have achieved the goal that we're after, is to project, or to place, excuse me, a checker pattern. A checker, just like, you know, black and white checker image on the actual model, okay? There's a fantastic preset that ships with Modo that I actually happen to really enjoy, okay? If you hit the F6 key on your keyboard, F6, it's going to open up your preset browser, okay? Now, inside of your preset browser, we have a number of different things here. I'm going to go into Materials, expand that bad boy. And where we're going is the miscellaneous category. And we have a subcategory here called UV Checker. And there it is. It's this rainbow color. You're going to see me using this everywhere because it's a great image that allows us to just visually double check if we're close to what we think we need the final result to be. Let's just go ahead and double click on the preset to automatically apply the preset to our material group. And so it's under miscellaneous. Materials, miscellaneous. Wow. So is it not showing up on your? When you open up your preset browsers, do you get anything?
So hit F6 and go into
open up, oh, so miscellaneous isn't even in there. That's just, yeah, you could use it under images. That's fine, okay? So if instead of going in, the material preset automatically loads the image for you. It's interesting to me that you guys don't have it showing up. And what Mr. Moriarty is talking about here, if you go into images, expand that hierarchy, let's see. Now I got to remember where it is. Miscellaneous, I think, under UV. Okay. There we go, UV. Yeah, and what I'm using is this guy down here. The preset automatically loads this UV checker texture into the material group, and it assigns the correct projection type kind of automatically for us. But you can manually do it by going into the images. All right, let's just take a step back and talk about what we've come up with here. All right. So it looks as though there's no texture on side of my cube. What is going on? I need to see that checker pattern. In my shader tree, I can see that my checker pattern is in the material group, right? But I'm not seeing it. Why not? What do I need to go in and change? So the image, right? I have the image selected in my shader tree. Now remember, what's responsible for placing this image on my model? Before we get to the projection type, what's responsible for placing the image on the model? It's even on the screen right now if you're hunting for it. Texture locator. Okay, texture locator. The texture locator is fundamentally responsible for placing the image on our three-dimensional model. So if I go into the texture locator tab, okay, we can start working with it. Now this happens often, okay? The projection type is set to UV map, rock and roll. However, it's still not showing up. What do I need to do next? Yeah, go ahead, Andrew.
Change it to select the UV map cube.
You got it. So UV map, if you go down to this guy, we have to direct it towards the correct UV map. At times, it will randomly pick one, or it won't pick one, like you just saw on my screen. But we have to go in and tell the computer which UV map to use, okay? All right, so, and boom, the moment I hit box, which is the name of my UV map, you can see what's going on. You can see the texture beautifully, well, kind of beautifully displayed across my little cube. Questions? I hear some people getting a little confused. Yeah, Thomas, go ahead. Hit me. Okay. Thomas, what computer number are you? Student 17. Let's take a look. All right, let's see what Tom's got. Okay, so it didn't actually apply the image into your material group. What are you going to do with that? Did you double click it? Okay, try doing this. Try dragging and dropping it into the material group. Or right there, that works. Do you see how you got that little hover event? Oops. Did it just quit? Yeah, awesome. Reopen. Yeah. So if you're getting stuck on it, if you're not able to put the image, if it doesn't automatically go into your material group, check it out. Here's what I want you to do. It's super easy. Okay, just take the image from your preset browser and drag it over here into your shader tree. Okay, now I have two of them in there. You can try doing this where you can just drag and drop it onto an object, but I find that dangerous. Okay? Okay. All right. I'll see if I can work on getting that material preset for you guys, because it really is much, much nicer to use that material preset. I'm thinking that maybe some content wasn't installed when we upgraded to 701, so I'll revisit that this week and see if I can get that material preset installed for you guys, okay? Or during a break. while we're here, let's talk about the big picture idea, because this is the most important part, okay? We're using this checker pattern to kind of double check our work, to see if we're in the right ballpark. Yes, sir?
I use Atlas to make my UV thing. Is it okay if they're not connected like that? 'Cause they're all
Yes. We'll talk about Atlas here in a minute, okay? But let's just kind of focus on what I've created here first, okay? Because there's some big ideas in here that are going to be prevalent going forward, all right? Now, earlier I mentioned that we need to have the size, scale, and proportions of our UV islands match their three-dimensional counterpart, right? I know beyond any reasonable doubt what I got over here are perfect squares. What we have that was automatically generated by Modo are rectangles, okay? Look critically at the texture that's been mapped to our object. And I want to focus my attention on square E05, this one right here. And let's see, yeah, there's E05 there in the background of my image, okay? Do they look the same? No. What's different about it? What's different?
It's darker.
And I think most importantly, Mr. Morris, I think you have it.
It's square on the UV map and not square on the...
You got it. They're all stretched out. The texture is being stretched across the surface of our geometry. So this is the original image. This is just a JPEG that's just kind of in preview mode in the background of our UV grid. And then we can see precisely how that JPEG is being texture mapped onto our three-dimensional model on the right. They don't match, right? This is an issue. They don't match. This is called the distortion. A distortion in our UVs that's causing the texture to incorrectly be wrapped across the surface of our geometry.
Is that the reason that they're all squares?
Yes, that's why we use this pattern, so it's easy to see where, yeah, so it's really easy for our eyeballs to see where they're stretched, okay? Because now we have a point of reference, right? We know that all the squares on the texture need to be square. Kind of make sense? Yeah? So the question, how do we fix it, right? How do we fix it? Let's make a really extreme example so you guys can understand what I'm talking about, and then we'll talk about how we can fix it. All right, I'm going to grab, let's see, that edge, which is that guy over there, and I'm going to move that edge up. Yeah. Because we have an odd-shaped UV, you can see precisely how that UV is interpreting or how that UV is wrapping the texture around our object. Our coloring book is inaccurate, okay? We don't have the correct shape on the pattern of our dress, and the texture is not showing up on our model correctly, okay? This is something that we have to manage. This is the nightmare of UV mapping, is eliminating these distortions, or at the very least, minimizing their apparent nature within our scene and trying to squash the bugs, okay? So the question remains, how do we fix it, right? Well, let's talk about one of the basic tools that we're going to be using this week to get what we want. Pop quiz. I have some UVs sitting over there on my left. How do I delete them? I don't want to delete my map, just want to delete my UVs. Give me one of the 4 ways that we talked about. Yeah, Raphael, hit me.
Go to lists, right-click on your UV map.
Yep, I love it. So you can go to lists, UV map, you can right-click on it, you can clear it, bam, that's one way, perfect. Now, did we physically delete that texture from our scene? No, we've deleted the UVs so the texture doesn't know where to place, or excuse me, the texture locator doesn't know where to place the image on my model. What's another way of deleting the UVs? So over here in your toolbars, right? I love it. Edit UVs. Delete UVs, that works, okay? Or you can right-click on the UVs in the UV grid, choose delete from the contextual menu that pops up, or texture, UV operators, delete, okay? Just that simple. All right. So let's talk about how we're going to make some UVs, because the ones that Modo make, not fantastic. Not fantastic. They're always going to be kind of off, okay? Man, it sure would be nice if I could work without that image just chilling there in the grid. Has anyone stumbled on how to remove that image? Click the gear. Yep, that's this. It's a little setting up there. You could do that. Absolutely. I tend not to do this. And where we're going here, Mr. Dobbs, is in here, right? Where we can do show image. Turns off. That's fine. That works. Filter and choose what? Turn off the image, but it's still over here. Here's why we're getting this image showing up in the background of our UV area. It's so easy, it's hard. And I remember getting stumped on this when I was in your shoes. Yeah, it's selected. See how it's selected in the shader tree? Whatever image is selected in the shader tree is going to be placed in the background of your UV grid. Okay, so that's the easy way. And that's the way I like to work because I haven't changed any of the function of Modo. I've just told the computer what to display. Here's what I historically do. I just select the base shader, okay, or the base material for that matter, and the texture in the background of my UV grid goes away. Okay. See, there it's on, there it's off. Okay. Now let's do some work. Okay, let's do some work on our little guy. All right. So we need to make some UVs. Making UVs in Modo is not actually hard. Making good UVs is the really difficult part. Okay. However, there are some really great tools inside of the Modoverse that allow us to very quickly make good, usable UVs. Today we're going to focus on two of them. We're going to focus on the lovely Project from View tool. And we're also going to kind of conclude our conversation today by talking about the UV projection tool. Okay? Let's start with the Project from View tool. Okay? You can find our UV creation tools in the upper left-hand corner of our toolbar. There they are. UV projection tool, the Project from View tool, and then the UV unwrap tool. UV unwrap is my favorite. I wish every app had UV unwrap. They should license that technology, in my opinion, because it is that good. It's really kind of amazing. Okay, we're going to start off by talking about Project from View. Earlier in the day, I said that a UV island is nothing more than a 2D representation of our three-dimensional polygons, right? The Project from View tool, in every sense, is going to allow us to take snapshots of those three-dimensional polygons and make two-dimensional UVs. It's really easy to use. Let me zoom out real fast. As with everything inside of Modo, it begins and ends with a selection. As you can see, I've selected that leftmost polygon on my cube. With that selected, I can go back to my Project from View tool. Boom. And now I need to direct the computer to the OpenGL viewport that I wish it to make a snapshot from. Okay? That we are, in every sense, taking a picture of a polygon. So we need to put our mouse cursor in this OpenGL viewport and then click. That's all we got to do. Once we click, clicky-click, whoop, aha, there it is. Congratulations, you've just made your first UV. Woo! Yes, sir.
Doesn't look like it. Looks like took an exact picture.
It's an exact picture. James has it precisely correct. It is an exact picture of how my eyeball or how the user's perspective is currently viewing that polygon. So if you look at our UV island over here on the left, what's wrong with it? Is it a square? Yeah, no, it's not a square. It's a cool little, what is it, a trapezoid, a rhombus, something like that? I don't know. I'm not a math teacher. But it's not square, I can tell you that. Okay? Yeah?
If you don't select a face and do it, it'll just take a picture of the entire cube?
Yeah, I would imagine. Or nothing at all.
No, it took the entire cube.
Okay, great. We begin and end everything in Modo with a selection. Okay? You can also see that we have some issues with the texture itself, right? Look at the texture on the three-dimensional model. What's wrong with it? It's all warped. It's distorted. It doesn't look like it should, right? We're not seeing a perfect uniform grid of colored cubes showing up across the surface of our geometry. It's got this really odd bend in it. That's no bueno. That's not good. Okay, so we've got to fix that. So here's how we're going to fix it. In order for us to get good, accurate, distortion-free UVs, we have to change our eyeball's perspective of that polygon to be in perfectly parallel to that polygon, right? Control Shift A. If there's one thing that you inscribe upon the palm of your hand, Control Shift A. Make sure you have a polygon selected first. Okay? Let me show you what I'm talking about. I'm going to grab that polygon that I just incorrectly UV mapped, and I'm going to hold down the Control Shift A key, and bam, look what it's done. It's automatically moved my OpenGL perspective camera to be perfectly parallel to the perspective, or to the polygon that I clicked on, right? It's perfectly parallel. Imagine that they're in front of you, that there's a plane that perfectly matches the orientation of your face, right? That plane of your face, that plane of your eyeballs is now parallel to that polygon. That's what we're after. In layman's term, we're looking like dead on at it, okay? We're looking dead on, and you can see that it's a perfect cube over there in my OpenGL viewport. So how do I take a picture of it? How do I create a UV? Same way as we did before, which was? UV projection tool. You got it. Do I have to have the polygon selected before I fire this tool off? Yes. Then what do? Click on the OpenGL viewport. You got it. And the computer's going to take a picture, boom, of that face. Yours is flat. It's not showing a line. Did you click on the, did you fire? Now, remember, okay, UV project, you want to use project from view, not the UV projection tool. Okay, you want to use the project from view tool, not the UV projection tool. There is, it's the number 2 tool in the list. I understand that definitely generates some level of confusion. I apologize. We're working with the number 2 tool in our list of tools. All right. So now if we take a look at what we've accomplished, things are looking good, right? We have a perfect square over here, and we're getting a perfect reproduction of our texture on the polygon itself. Rock and roll. Things are looking good. Okay? Things are looking good. So let's do it again. Let's do it again. I want to do it on a different face. Let's do this one over here. So walk me through the process. I want to make a UV island for this bad boy right here. Okay, walk me through it. What do I got to do? Select it, then what? Control Shift A. Let's do it real fast. So select it, Control Shift A, then what? Project from view. Then what? Clicky click. Boom! Mission accomplished, right? If we drop the tool and spin around in perspective, now we're getting what we're after. Okay? However, this brings us to a unique kind of moment in the day. Yeah, what's different about our UV grid now? They're red, right? They're red. And go ahead. They're overlapping, okay? Now we have 2 independent UV islands that are sharing the exact same space within inside of our grid. This is called overlapping UVs. It's allowed. We can do this. We do this quite often, okay? This is something that's definitely legit. You can do this. However, what can you tell me about how the texture is being displayed on both of those polygons? It's displaying the exact same texture, okay? Can be a little bit of an issue from time to time, especially if we wanted to have the left side of my box be painted separately and differently from the right side of my box, right? If I wanted them to look different from one another, like you saw in my earlier example with my crate, what do we have to do? Does anyone know? We're going to move them around a little bit. Okay. In addition, we also have to make them smaller. Okay. So check it out. We need to do what's called a little UV editing now. We've made our UVs. Now we got to do some editing. Okay. Let's jump in and do it real fast. Okay, I'm going to go into my polygon selection set, and notice that when I clicked on my UVs on the left, it automatically selected both of the polygons on the right. This is to be something that you need to keep your eyeballs on, okay? Since they're right on top of each other, it's impossible for us to select each individual polygon on the left side, okay? So you select them on the right side, absolutely. So if I wanted to separate these bad boys out, I got to use the rightmost OpenGL viewport to get what I need. Notice that I've selected it over here. If I fire off the move tool while my cursor is in the OpenGL viewport, it's just going to be a standard move tool. Whoops. Okay? Keep that in mind as well. If I wanted to move things, put your cursor over here, then fire off the move tool, and then it will just move the UVs. Here we go. And now we've separated them out. They're no longer overlapping, and we can texture them independently from each other. However, we've solved one problem, but we've now created another problem. Earlier, at the beginning of the day, I mentioned that all of our UV islands need to be where? Inside what? Sector 2, right? The positive UV quadrant, right? Which is which quadrant on my screen? Top right, okay? I have one UV island in that quadrant, rock and roll. But I also have one UV island outside of that quadrant. What do I need to do? Make it smaller, absolutely, okay? So we've moved our UVs, now we're going to scale them. Let's select them, fire off the scale tool. I'm just going to make them smaller. And ideally, I need to make them smaller and then move them until they're on the interior of my upper right-hand quadrant of my grid, okay? Here we go. Let me hit undo a couple steps. There we go. That's what I started with. So then I just scaled them, hit the R key, or fire off the scale tool. It's right there. Then I made them smaller, and then I just moved them. This process that I've just finished is called packing. We're packing the UVs in the upper right-hand quadrant of our grid. We're getting all these little squares inside that area. Yes, sir? It's supposed to move the image. Absolutely. It's going to move the image. Right. It's going to move the image. So the placement of these UV islands within inside of our grid, or excuse me, within inside of our quadrant is going to have a direct reflection as to what portions of that texture are going to show up where. This is where we get the control that we're ultimately after with UV mapping. We're no longer allowing the computer to kind of automagically figure out where it wants to place texture information. We're determining where that texture information is being displayed on the image by the placement of our UV islands within that positive grid. Okay? So we're in the driver's seat, which is pretty great. Questions? Everyone's good. Kind of understanding the big picture idea. Yeah? Jawohl? Okay. I want to go back a couple steps here. Just hit the undo tool. And just to get both of my little guys here gigantic. Because Pat no liking manual manipulation of UVs, especially when all I'm trying to do is make them smaller. That's all I'm trying to do, right? There are a couple different other tools inside of our tool pipe here that will allow the computer to do exactly what I just did. Because think about this, I'm only working with 2 UVs. What if you have like 1,000 UV islands, separate UV islands that you need to pack inside? Well, hopefully you don't have 1,000 because that's kind of a nightmare. But what if you have like 10, right? That's a lot. That's a lot, right? I don't want to have to deal with that, okay? I don't have to deal with each one of those independently, especially when all I'm trying to do is to pack them inside of my upper right-hand quadrant, right? The computer should do this for us, and it can. There's a great tool inside of our toolbar called Pack UVs. Notice that I have both of my UV islands selected, and I always forget where it is. There it is, Pack UVs. You click on it, you're going to get a little popover. And it says, what would you like to do? Would you like me to pack it, which is just a fancy word for move? Stretch and orient. Well, I definitely want it to pack it, but I don't want it to rotate this at all. So I'm just going to hit pack and boom. It automatically scaled and moved those two UV islands to fit within inside the upper UV quadrant. It's pack UVs, pack. Okay? So much better, right? So much better. Okay? Yeah, absolutely. Let me hit undo. It all starts with a selection. So I got my two UVs selected, rock and roll. And you can find pack UVs kind of in the middle of your UV toolbar. It's right there, pack UVs. You click on it, you'll get a little popover. And this little popover is basically asking you what you would like the command to do. Pack, stretch, and orient. In my mind, this is move, scale, and rotate. Okay, that's kind of what it's doing. We definitely would like it to move my UV islands, and I definitely would like it to scale my UV islands, but I don't want to rotate them 90 degrees. Okay, I've already done that. So I'm just going to uncheck orient and then hit OK. Boop. There it is. Huzzah. It can at times. It can at times. The stretch is a dangerous one, but it's important that we know it's there. It's going to try to do its best to keep the aspect ratio of the UVs. At times, it won't do that. Yeah, in that case, you have to do it manually. Okay, so let me just, all right. So that's the project from view tool. We're going to use that a lot in here. Project from view is one of my faves. You're going to find me using that all the time. However, it's not the only tool that we have at our disposal. We also have two other tools whose sole responsibility is to generate UV islands for us as well. I want to spend some time talking about the UV projection tool, which is the first tool inside of our list. Now that we kind of know what we're doing when it comes to making UVs, let's increase the complexity of the tools that we're using. The UV projection tool is kind of a nice one to have in our back pocket. However, it's only really applicable for unit primitives. Let me show you what I'm talking about. Earlier today, we spent some time focusing on the texture, the image map projection system, right? And you saw the abysmal results that I was getting pretty quickly, right? It was just horrible. Projection mapping is just a monumental waste of my time. However, those ideas, those same rules, find their way into the UV mapping world, which is, yeah, that's good, right? Check it out. This only works with unit primitives, and I would only really recommend that you use it with unit primitives, but it's pretty neat. Okay, so here's the UV projection tool. Oops, I forgot to select my cube. Excuse me. I want to double click on the entirety of my cube. Boom. And then UV projection tool. Now this works off of a series of rules. Those rules can be changed inside of our tool options on the bottom half of our toolbar. These guys down here. Okay? You can see it, and let me make my interface just a little bit bigger. There we go. You can see that we're working with those exact same projection types that we were experiencing in our shader tree. This is basically going to create UV islands for us that match this projection type. So we don't want spherical because it's not a sphere. But let's do, let's see, planar. Planar's not going to give us what we want, I think. I so rarely use this. Let's just do it. Boom, yeah, planar's not what we want. We want to use one that's called Atlas. And even then, let's do Atlas 2, excuse me. Even then, it's not perfect for cubes. Oh, there's cubic at the bottom. Why didn't I see that? Sorry. That's the one we wanted, cubic. Okay. Aha, mission accomplished. Now, it's made UV islands for all 6 of my faces simultaneously, but they are stacked on top of each other. We're getting that red outline in our UV grid now. How do I fix this, Mr. Pearson? Pack. Let's do it. Great job. So let's go pack UVs. Hit OK. Boom. There it is. And we're done. Okay? Very quick, very easy. Only really applicable for primitive shapes. Okay? For primitive shapes. Only really applicable. All right? Let me illustrate this going one step further. Yes, sir?
So if you were UV mapping something really complex, you wouldn't use the project.
Yes. in combination with the UV unwrap, which we're going to talk about next week. UV unwrap is ultimately going to give you the most control and the best results, in my opinion. Okay, so I want to make a new item here. I want to make another unit primitive in a new mesh, and I'm just going to do a sphere. There it is. Okay, and you can see here's the UVs that Modo automatically tried to create for us. It does a bad job, so we're going to delete them. All right. Now, this is where, when we start adding different mesh items into the mix, it gets a little confusing, okay? And I apologize for this. If the guys down at Luxology are listening to my live stream, you need to fix this, okay? Because this is an area that you guys are going to get confused on. UV maps exist on items, okay? They're a child of an item. So I have two different items within my scene right now. I got the sphere and the cube. How many different UV maps do I have right now? Two. One's on the cube, one's on the sphere. One's on the sphere. I deleted the islands, not the map. The map still exists. This is where the confusion kind of reigns, and I apologize. Right now, the duplicate is also called box. It's always going to adopt the name of the previous item that you had selected within the scene, and it's kind of lame. I really just wish it would just be like untitled or something like that. You have to manage this, okay? Only you can prevent forest fires, okay? We start building the muscle today of naming our UV maps, okay? If you don't name them, you're going to get stuck in a situation where all of your UV maps are named texture, okay? Or untitled. That's stupid, okay? Because you're going to be confused. You're going to be confused. You're just fundamentally going to be confused as to which UV map is responsible for shading which polygons in your scene. So I'm going to change this. Sphere. Okay, so now I got one that's sphere. The sphere UV map is on the sphere mesh item. And then on my cube, you can see that the moment I clicked on my cube mesh item, it's displaying all the UV map that are associated with that item, okay? Two separate items, two separate UV maps. UV maps are connected to mesh items. They're part of the item's definitions. Here's my sphere UV map. Here's my cube mesh item, and it's showing me my box UV map. When I click on my box UV map, it shows me the corresponding UVs. How many UV maps can you have on an item? Huh? Several. As many as you want. As many as you want, if you're working at Pixar. For us in the game world, uno. We'll get one. We'll get one UV map per item, okay? Per item. Okay, we're only allowed to have one, okay?
Can we have one UV map with multiple pictures attached to it?
Multiple pictures.
Like two different backdrops.
Yes. Yeah, I'm not going to go into that today because that's going to get people confused. But the bigger question is yes, you can. Yeah. Okay. All right, so let's go back to our sphere and start talking about how we can. Oh, real quick. Hold on a sec. I just realized I forgot to mention something. Now, if you look at my item list, pop quiz, okay? Which items in my item list are currently visible?
Just the sphere.
Visible, not active, visible. Both. Both. How do we know? So easy, it's hard. Yeah, there's a little, eyeball icon next to that item, right? Denoting its visibility. So my cube is still visible within the scene. I can even see the black wireframe of that cube in the background over there in my OpenGL viewport, right? What do you see in my UV grid? Yeah, you got it, Thomas. The cube's UV islands, right? We can see the black wireframe outlines of all the other, of all those other UVs. Okay. Modo by default is automatically going to show any background items UVs in the UV grid. Okay. Kind of a little bit of an organizational nightmare. Okay. Can you see what I'm talking about? Like these cool little black wireframe outlines that correspond with the UVs of my cube. Okay. Has anyone stumbled on how we can get rid of those? Bingo. Mr. Virga's got it. Turn off the visibility of your cube. Boom. And the visibility of the UV islands inside the UV grid also go away. So keep that in mind. A lot of people get confused. They're like, can I still work with those? Yeah, but they're in another item, right? It's on a separate item in a separate UV map. However, we still can see those items in the background of our UV grid. What? Why would you want to do that, though? But you're making it more complex. What if I need to have both of these items in this three-dimensional scene? Change the, I don't quite follow. Yeah, the answer to your question is no. You have to do this. Okay, yeah, you have to turn. If you don't want to see the, and this is purely a preference. Okay, if your brain can decode it, good for you. That's awesome. My brain can't decode it. I'm a simple machine. Okay, I want to focus my attention on the white UV islands within the grid, so I'm going to turn the visibility of all those background layers off. Okay. Okay, so let's make some UVs of this thing. Earlier we were using the UV projection tool. Let's just do it real quick. So I've selected it, UV projection tool. Which projection type am I going to use down here? So here are the options. Which one? Spherical, right? Spherical, because it's not a cube, it's not a cylinder, it's not barycentric. I don't even know what that does. No, it's just a different algorithm to unwrap it. It's a sphere, so we want to use the spherical projection type. Much like our projection types that we were working with in the shader tree, we have to pick a corresponding projection axis. Now, the projection axis on a sphere and a cylinder is kind of determined by where the poles of the sphere and the cylinder are oriented within our scene. Based on what you can see in my OpenGL viewport, which projection axis should I use? Why? You got it. That's where the poles are facing, okay? And specifically what I'm talking about here are these things. These are the poles, okay? These are the poles. Imagine this like good old Mother Earth here, okay? We have, you know, the equator is kind of like right around in here. This is the North Pole. This is the South Pole, okay? We zero in on the orientation of those poles within inside of our three-dimensional scene. The projection axis is told to us, okay? Right now, those poles are oriented along the y-axis, and I know that just by looking at the compass, okay? All right, let's do it. Let's click. Boom. Aha. Cool. We've done it. Yay. Mission accomplished. Now with spheres, you can get those little triangles down at the bottom, because if you were to examine the actual model itself, the poles are constructed through a whole series of triangles. Is what? The top is being rendered differently. Show me. Yeah, that's odd. Here, let's do this. Drop the tool, hit undo, couple steps, and let's do it again. Now, real quick, Thomas, before you go any further, is this sphere centered at the origin of your scene? Negativo. That's having an impact on it. Yeah, you had it right. Now let's try running it. No, still going off. Interesting. Okay, let's figure. What action center are you currently using? Drop your tool for me. Go to the top of the screen, right there where it says Action Center. Okay, it's off. That's interesting. Okay, so what was different about his compared to mine? Now I'm curious. Work plane, that could be it. Could be it. Go to the top of your OpenGL viewport, Thomas, where it says work plane. Yeah, reset it for me. Nope, that's not it. That's interesting to me. Try, before we go any further, try changing the axis on your, yeah. Okay, I'm going to go back to Y. Interesting. It doesn't like you today, Thomas. It's sort of doing the same thing for you guys? Okay. Well, here's what I want. Here's the big picture idea. You're almost never going to be using this. Almost never. But I wanted it to be, you guys to be aware that it's there. Okay? This is only truly an applicable tool for unit primitives. Okay? If you tried it in Atlas is maybe the only other projection type that you'd use, but you're not allowed to use that. Okay? Because that's bad technique. Okay? I'm not Mr. Automatic, and the Atlas projection type will get you into trouble big time, okay? So you're not allowed to use it, okay, because it doesn't produce the type of UV accuracy that we ultimately require to do the type of work that we're doing here, okay? So I don't know what's going on here, man. That's kind of odd. That's very odd. Do me a favor, Thomas, drop the tool, go back in time a couple steps by hitting undo, and hit tab. There we go. Now you've unsubdivided it. And try it again. See if that has an impact on it. That's okay. Don't worry about it. It's all good. It's not your fault. You're not doing anything wrong. Everything is still copacetic. Interesting. Mesh cleanup is not going to fix UV problems. Well, it's not going to fix this UV problem. Okay? So yeah, that's a fun one. It's not ripping it apart also. Hey Thomas, can you do this? Can you hit this button right here? Hold on a sec. Let me compare that to my screen and see if there's any sort of noticeable difference. And there's not. Interesting. That is an odd one. That is an odd one because ultimately what you'd get is something like this. Or, excuse me. This is really what you're after or something like this. That's okay. It's all good. I'll just dock it from your pay later. No, you're all good, man. Okay. You know, whenever you run into a bug like this, and I'm starting to think this is actually a bug, try this, Thomas. Go to the top of your screen where it says File. At the bottom of that list, there's an option called Reset. It's going to reset Moto back to its factory configuration file. Sometimes that works. Only if you want to. I wouldn't. I'd start over. It's just a sphere. So sometimes resetting Moto will resolve some of the issues that pop up during the production. Okay. Questions. Everyone good? Kind of understanding the big picture idea here? Yes, sir.
Isn't that automatic one you just made, the UV map, isn't that still kind of inaccurate because the lines are straight?
Absolutely. It's still not going to give us a fantastic result. Spherical objects are the toughest objects to UV map. It really is. And let's kind of illustrate that for a second here, Raphael. I'm going to take that object and let's make a new material. I'll call it sphere. And over in my shader tree, check this action out. I'm just going to, this is what I love. I'm just going to grab that image and I'm going to drag it into sphere and then adjust its texture locator and to direct it towards the correct UV map. Oh, looks like it's already on there. So if I already not seeing it, well, that's because I don't think I have any UVs right now. Aha. Okay, let's do it real fast. Let's go back to automatic. Huzzah, and then there it is. Even when I subdivide it and smooth it all out, it's still not fantastic, but it gets the job done. This is better than some of the other UV maps that will automatically be generated. Not perfect and ideal. Thomas, looks like that you got it working now. I'm spying on you. So it's not perfect, but it's a step in the right direction. The UV unwrap tool will give you a better result.
For a perfect sphere, would you just project from view every single polygon? Or
So that brings up a really interesting question, doesn't it? You know, Raphael said, if you wanted a perfect representation of all the polygons, would you do project from view on every single polygon? No. Yeah, that's insane. That's insane. You certainly could. However, as we will start to experience next week, whenever we have separate UV islands, okay, within a map, we're going to have a seam, a noticeable seam along the mesh. Masking those seams is a challenge that we have to work towards, or work around, actually. It's kind of a pain in the butt. So in theory, yeah, you could, but I think in actuality, it's one of those issues that you don't want to, yeah. It is not uncommon to spend more time UV mapping than you do modeling. Yeah. Yeah, which is everyone's kind of shaking their heads right now and smiling and chuckling, but you will experience this in action here shortly. But the results are pretty staggering. Let me show you something here. When you get to, what am I doing? I think this will probably illustrate the benefits of this entire thing here. Where am I going? Go. I think I've shown this little QuickTime file to some of you in here. This is a Jeep I made a couple summers ago, and I always like the summer months because it gives me an opportunity to continue to refine and kind of flex my skill on a lot of different levels. And on this project, the big challenge for me was to UV map everything. Okay? In my mind, I wanted to have a UV map for everything, okay? Which is not impossible. Glad to see you're paying attention now. That's awesome. As he plays a video game. You know, it's for the feature film pipeline, you don't need to have a UV map for everything, but I like holding myself to that standard. And let me show you what I'm talking about. Here's the model. Okay. This is a 1942 Jeep Willys. Kind of a cool model. Like the good old World War II Army Jeep. There's the model itself. This is the raw geometry coming right out of Moto, and this is definitely not a game art asset, okay? Definitely not a game art asset. However, you'll see here momentarily that there's all the UV maps, okay? And what we get from this process of spending a lot of time ensuring that the UV maps that we craft are distortion-free is the ability to go in and use the interactive texture painting system either in Photoshop or in Moto to give us some really great results at the end of the day. And there it is all painted out with the textures on there, okay? Pretty great. It's a pretty neat process, okay? Allows us to get a significant amount of detail quickly in very specific areas within the mesh itself. Okay. For example, let me just open up the project file and show you why we truly do this. Okay. We go through great pains to make all these UVs. We go through great pains to make all these UVs. Come on. There it is. Now, I haven't actually opened this project file in 701, so I'm expecting it to not go well. Ah, actually, it went very well. Okay, so here's my Jeep. Okay. And as you can see, it's quite complex, and a couple tricks up my sleeve. Did I model the entire Jeep? No, I only modeled half of it, and then I just mirrored it across the x-axis. Awesome. I'm always looking for opportunities to do half the work. However, let's take a look at some of the objects in the back. Here's my cool little gas tank. There it is. Without UVs, I wouldn't be able to go in and paint specific detail in specific areas within my mesh. Okay. Allows us to put very specific texture information where I want it to go. Nothing's random. Nothing's automatically generated. I'm in the driver's seat as to where all this texture detail goes. It's pretty great. And let me show you the UV maps. So there's the UVs, the corresponding UV map just for the gas tank. Yeah, pretty cool. Pretty cool. It gets pretty complex pretty quickly. It's one of those things that after a while, it's kind of like the Matrix. At first, you just see the code, but after a while, you start seeing the figures within the code, okay? Like, I can see the gas tank in all of these outlines. This is the pattern, if you will. If I was to take this gas tank, or take these UV islands, and then, kind of trace them on pieces of cardboard, I could bend the cardboard into a gas tank shape at the end of the day. It's the exact same principle and idea. Pretty neat, huh? Pretty neat. That's why we do it. That's why we do it. It's a whole lot of fun. Let me show you something that I would not recommend that you ever do. Like I said, intellectual, academic perspective on 3D modeling. I would never, ever do this on an actual production asset, but since it's for me and my portfolio, I certainly could. Here's my 50 cal. Turned out really great, right? Awesome looking 50 cal. Yeah, pretty fantastic. I think I did a pretty decent job on it. However, we have one small massive issue when it comes, oops, excuse me. Let me just turn off. All right. So there's one thing in here that I would not recommend that you ever do. Alrighty, folks, let's get back to it, shall we? It's go time. It's go time. Okay. All right, so we need to conclude our day today by talking about the last tool inside of our UV mapping pipeline, and that's the UV Unwrap tool. Okay, UV Unwrap is fantastic. I love UV Unwrap. I love it, love it, love it. I love it so much that I'm going to talk about it today. I wasn't necessarily going to talk about it today, but I am. Whoa. Oh, wait, that's me. That's me live on the internet. Sorry, I was. You're watching my live stream? Okay, great. So, okay, actually, I'm on the wrong computer too. Let's put it back here. Okay. Well, yeah, I already have the homework done. You know? So this is our goal for this week, is to make a wine barrel. I want you guys to focus entirely on the geometry of your wine barrel this week. We're going to start looking at Photoshop next week because I wanted to slow down. I looked at the clock and I don't have enough time to talk about the UV Unwrap tool and working in Photoshop in its entirety today. So we're just going to focus on UVs today. And then next week, we're going to spend the entirety of our time texturing our wine barrel. Okay? Sound good? Because I don't want to rush through it. It's such an important idea that if I rush through it, you guys would be lost. And this is the foundation going forward. So this is what we're going to be striving to create this week. Okay? Now, we're not limited. There is no polygonal budget associated with this project. But don't go crazy with it either. Okay? Whenever we're designing three-dimensional objects for our game engines, we often have to think and consider how this object is going to be used within that game. This is going to be a background prop piece. So does it need to be extraordinarily high resolution? Yeah. Yes, we're gonna blow our entire budget on a barrel, right? Yeah. It's the barrel. Now, if it is the barrel that the gamer interacts with and it's like, you know, super close to the camera, then maybe we want to have it be of good resolution. But if it's something that we're going to pass, you know, on the level, if it's just a detail that we never really truly focus on, we don't want to waste our budget on something like that. What kind of objects do we want to spend all of our bit budget on, all of our polygonal budget on? Yeah. The things the gamer is physically going to interact with. So, you know, for example, if you're playing, you know, like a third-person action-adventure game, those character models are relatively large within the screen, and they're close to the gamer's perspective, right? So they're going to see all of the surface detail on that object. Those are the elements that need to be high resolution. Not buildings, not like a plant that you walk by. We can kind of take away from those objects, and put those polygons on our hero objects, the things that we actually play with, to kind of optimize our level. So not everything is going to get the same level of detail and the same resolution in a game. Okay, there is a pecking order. Characters, weapons, things you interact with, vehicles, those are going to get the majority of the polygons. Okay, and luckily, with the current generation, or I shouldn't say current, it's the next generation, the Xbox One, PS4 crowd, those models are looking pretty good. We're getting pretty high resolution video game models now. It's phenomenal. It's especially when you compare it to the interactive models that I first started working out with, right? Where like somebody's head was an octagon, right? And that was, I mean, it was crazy. You know, I worked, when I was working at MTV, some of the mouths of our characters were defined by like 4 points. It was crazy. I mean, it looked like a Muppet. You know, they'd just go like, it was horrible, right? There was no sort of attenuation or fine detail on the lips, and it looked like a puppet, right? It was horrible. Now we're not like that. Now there's a lot of polygons in these characters, and we're starting to get closer and closer and closer to what a lot of people think is the, you know, the brass ring, which is true photoreal gaming. And we're getting close to that. We really are. We're getting really close, really close. I don't think it's going to be this generation. I think the next gen, so whatever comes after Xbox One, perhaps Xbox 2, I don't know. I think that was a bad marketing decision on the Microsoft guys, right? Because now we have Xbox One, is Xbox 2, I don't know, just me. PS5, that one, whatever, you know, the next, in 10 years from now, we'll be at photoreal gaming.
Wasn't NVIDIA showing something where they had this hyper-realistic face and it was like...
You can do it. You can do it right now. I mean, I can throw a 10 million polygon character mesh into a game engine. I can do that. Yeah, it's just not going to run very well, right? You might, and it may be the only thing in the scene, right? You might have, one crazy high-resolution character mesh walking around on a plane, right? Just a flat cube, and that's it. You start adding in all those other elements that make a game, and we're going to have to start removing detail from our models.
So you think it's the hardware that's holding it up?
A little bit. I think it's a little bit. Yeah, I think there's a natural relationship between the software and the hardware. I think it's a little bit of the hardware.
You can hit a wall of production time.
That too.
Yeah, absolutely. It's there's a lot of variables that go into it, but I think there's a relationship there that you can't ignore. Yeah. Yeah, for sure. Okay, anyways, let's get back to our little wine barrel. So don't go crazy with the resolution, all right? If you look at my wine barrel, which represents a good place to start, okay? I created this with an 11-sided polygon, okay, 11-sided cylinder. Now, I did this intentionally to show you guys a big no-no in the game world, okay? Look at the top of my wine barrel, okay? Tippy top of my wine barrel. What is it made out of? The very central polygon. What is it?
I don't remember what you call that. Engon.
Hannah gets the gold star for the day, and as does James. Work together. It's an engon, right? What is an engon? Come on, Hannah. You said what it was. Bingo, there it is. It's a polygon or a surface with more than 4 points. It's an engon, right? So it's the N, go back to like 9th grade algebra, N, the letter N, gone, right? The N can be replaced with any number that's greater than 4 in this particular case, okay? This is a no-no for us in the interactive world. Why? We can't model with engons anymore. Yes, sir?
The game engines don't work with polygons like that.
You got it. The game engines...
4-sided or 3-sided.
Bingo. James has got it perfectly correct. Okay, game engines only understand triangles and quad polygons. That's it. Okay, that's it. Those are the only two surface types that are compliant. So what are we to do with that engon? Slice it up. Okay, we got to get rid of it. Okay. However, we have a little bit of an issue. Yes, sir. Go ahead, James. There is absolutely. There are a couple other methods of removing that engon from the surface. I want to show you how to resolve this little issue because it draws focus to an important modeling concept that we have to be aware of. Okay, we have an engon here, and let me just make the vertices on my mesh a little bit easier for you guys to see. I know way back in the back of the classroom. Here we go. Can be a little bit difficult. So there's all the verts on my mesh. All right. How would I slice this engon up to get it into quad polygons? What tool would I use? Let's just start there. Yeah, go ahead.
Edge slice.
Edge slice. All right, Quinn has got it right. Edge slice. Bam. You can find the edge slice tool under Mesh Edit. It's right there. Keyboard shortcut C. C as in Charlie. And it allows us to very quickly, there we go, start to slice up my mesh. I'm holding down the Shift key now. Start in the center of the edge, click over to a vert, and we're on our way. And then to resolve that 5-sider over here, we can just split it down the center. However, little bit of an issue, do we not? I can get a majority of that polygon sliced into quads, but because it's an 11-sided cylinder, we run into this issue. I can't actually slice it into quads. This is an issue for us, okay? Yes, sir? Triangles are okay. Yep. Yes, absolutely. Okay. Let's take a step back here, guys. Okay. This is not, a mod. There are 1,000 different ways. Let's focus. I'm showing you the right way to do it, not the only way to do it. Okay. And what's most important in this is that we cannot model with odd number sided cylinders. Okay. It's bad practice because you're always going to get stuck with this little issue at the end of the day. Okay. no odd numbered sided cylinders, okay? They got to be even sided cylinders so that we can very quickly slice up polygons into quads. It ensures that the entirety of this mesh can go into a quad polygon. I'm always going to be left with either a triangle or an n-gon at the top of my shape here, okay? If this is an even-sided cylinder, it'd be very, very easy for me to get this into quads, okay? Now, our gold standard is always quads. So in every sense, Ricardo, you're right. I could make this, I could make the entirety of the top of my cylinder here. I could do this, okay? I could grab all these, woo, and then woo, grab all those guys, and maybe just delete them. Go into edge mode and just fill that polygon, and then just run spiky on it, and this is cool. Boom, and we got triangles, okay? That works, okay? But, however, we want this to be a quad polygon mesh as much as we can. Why? What do quad polygons give us? Yeah. Flexibility, okay? It gives us shelf life for this model because now we have an asset that can very easily flow into the game world, and it can also flow into the feature film world, okay? Feature film rendering engines prefer quad polygons over triangles, okay? There's a lot of technology, especially when you hit that little tab key, right? Subdivide it, right? Subdivision surfaces know like the triangles. It loves quad polygons, okay? So it gives us flexibility within the art asset creation pipeline. We create one art asset that can be used in both the game world and in the feature film world without having to be remodeled, okay? You see this all the time. It was most, I think, prevalent with LucasArts, okay? I'm saddened that our game industry no longer includes LucasArts. I am bummed by that. I grew up on LucasArts games. It was, huh? Yeah, exactly. Right, exactly. So, and of course, LucasArts are most famous for doing all the Star Wars games, okay? Industrial Light and Magic and LucasArts, same building. They're in the exact same building, or they were in the exact same building down at the Presidio, okay? And one floor was LucasArts, on the other, 8 or 9 floors was Industrial Light and Magic, okay? They're in the exact same complex, and they worked so closely together that the LucasArts guys, the folks that were making the video games, took all the art assets that were physically used in the Star Wars film, and they kind of down-resed them and made them work inside the games, okay? One art asset that's used in 2 different locations, okay? Quad polygons give us that flexibility, okay? In addition, with the next couple, well, not soon, in about 6 or 7 weeks, we're going to talk about mesh sculpting through the lens of the game industry. The sculpting engines, and it doesn't matter which sculpting engine you're using, whether it be Mudbox, ZBrush, or Modo, they work the best with quad polygons, okay? So they're the most flexible. They allow us to transfer this information between a number of different production pipelines, and they give us access to some really great tools like sculpting, okay? So we want to use them. We want to use them as much as we can. Triangles, not my friend. I don't like triangles. In addition, it's really easy to take a quad polygon like this guy and transform it into a triangle, right? How? Yeah.
I would guess spiky.
Could do spiky, but there's an easier way. Yeah, just slice it in half, right? Just grab the edge slice tool, boom. Just by slicing it diagonally, I've turned one quad polygon mesh into 2 triangles. Okay, so every quad polygon can immediately be transformed into triangles. And the big secret that you'll start to explore towards the end of this semester is that when you dump all of these models into Unity, it's going to automatically triangulate them for you, okay? So game engines at the end of the day are going to get triangles, okay? But we want to have an asset that gives us the most flexibility. And all of our editing tools work best with quad polygons. What if I wanted to do a loop slice on this row right here? Can I do that with triangles in the way? No. Boom, it's just not going to work. It's not going to go all the way around. Because the moment that the loop interacts with that triangle, it stops the selection. So our editing tools work the best with quad polygons as well. They're the gold standard. Our brain should always think quad polygons, quad polygons, quad polygons. Okay, I'm going to jump up and down about that a lot this semester. Okay? Okay, all right. Let me go back in time here a little bit, get rid of that triangle. And I'm going to leave that as is. Okay, so I want to spend some time today just talking about how I'm going to make the UV map for this model. You guys can make this model. This is not a complex model. This is a relatively easy model. You can make almost the entirety of this model with which tool? Excuse me, can't talk this afternoon. Bevel tool, absolutely. This is, in essence, identical to the coffee cup that you did in the first week of GCOM 402. Okay, it's just a cylinder. Use the bevel tool. You can draw this shape very, very quickly. So I'm not going to focus on that. However, I do want to use this as an opportunity to focus on creating the UV maps for this shape. Now, let's see. Have I made the UVs for this guy already? I have. This is the result that we're after. Okay, here's the UVs. This is what we're after. Okay. This is what we are after when it comes to cylinders, okay? So let's talk about how we get here, okay? Part of the process of learning how to do UV mapping is understanding the thought process that goes along with the technique, okay? Because the tools are challenging, but we have to approach it from kind of an analytical perspective, okay? Step one. Whenever you're UV mapping a custom shape like this is not a unit primitive, so we don't get the luxury of using any of our lovely UV projection tools, okay? Project from view and the unwrap tool are our jam, okay? That's where we want to hang out. But there's a thought process that goes along with it. I always begin with the easiest things first. I'm all about little victories, I really am. Let's get the little things done out of the way, and then we can focus all of our attention and our brainwaves on the more complex areas of the mesh. Which are the easy parts of this object? No. What are the easy parts of the object? Why? Why the top and the bottom? They're flat, absolutely. The flat bits are always the easy parts, right? Because we can use project from view very quickly to generate the UVs. Let me illustrate this. So whenever I start UV mapping something, I always look for the areas on the mesh that are flat. In the fancy computer graphics term, planar, flat, a plane, right? Look for the planar areas of your mesh first. The tops and the bottoms are going to be that element for me. So I want to make a new UV map, and I'm just going to do this real fast. Call this just test. And we're going to make a new series of UVs for my little wine barrel. So I'm just going to go grab all of those guys. And I can use project from view, right? How do I use project from view? Control-Shift-A, right? What does Control-Shift-A do?
It centers the camera, doesn't it?
Yeah. Centers the camera to look directly on at the selected polygon, right? The plane of the user's face is now parallel to the plane of the polygons. Control-Shift-A, boom, there it is. Now how do I use the tool? Yeah, I got to activate the tool first. Project from view is the second tool in our toolbar, and then we got to click on the OpenGL viewport on the right. Boom! All right, huzzah! Nice. Woo! Good job. High five. First one done. Okay. Here's what I do, and I've noticed that Modo works the best when we focus it on making UV islands on only the polygons that we want it to work with, okay? So here's what I do. Whenever I've made my UVs, I'm happy with them, I hide them. Get them out of the way. That way we focus on, that way we ensure we don't accidentally screw them up, and we focus the application on making UVs for the polygons that are left, okay? H is hide. H is hide. Let's do the bottom. So grab all those guys, Control-Shift-A. Project from view, clicky click, there it is. Let's unhide what we have, and this is what we got. Okay, we have the tops and the bottoms. How do I get both the top and the bottom in a place where they're not right on top of each other? Pack. Pack UVs is going to allow us to separate these two and get them in separate areas. So let's do pack UVs real fast. Select them both. Boom. Okay, good. Here's another thing that I kind of find helpful as we go through this process. Where are all of my UVs being created in the grid? Over here. Yeah, in that upper right-hand quadrant, and more specifically, in the center of that quadrant, right? Everything is going to be centered in that quadrant. It's going to kind of turn into a little bit of an organizational mess in there. So here's what I do. The moment I have my UVs created, I move them out of that area. So that way, when I make the next series of UVs, they're not all right on top of each other. Okay, just kind of separates them out, then we can pack them later. It's all about making it easy for your brain. Just move them out of the way. Whoop, there we go. Just move them up there, that's fine. And then let's just hide these two chunks, H key, and this is what we have left. So this is the lion's share of the model itself. Now it's a cylinder, right? But it's a cylinder that's got some really cool details on it. I got some geometry for some metal straps. I also got some geometry for some rivets that kind of hold those metal straps together. I'm going to just hide those rivets real fast. Select this, Shift H will get rid of all the unselected polygons. Okay, and now I have just the barrel. It's all one piece, as it should be. Okay, it's all one piece, or as it can be, Whenever we're working with UVs, it's a challenge, or part of the challenge is figuring out which tools are going to yield us the best result. I don't know what tool is going to yield me the best result. I have some ideas, right? But I'm going to have to experiment, okay? UV mapping is one of those things that you just kind of have to doodle with it, okay? It's not the best answer, and it's usually the one thing that people don't want to do is just kind of fiddle with it for a bit, right? You're going to have to experiment. You almost never get it right the first time. Almost never, okay? I'm a pretty good UV mapper. I UV map everything, and I've gotten to the point now where I kind of see things in UVs, which is unfortunate for my brain. It's like I look at something and my brain immediately, like I can figure out just by looking at something where I need to slice all my objects to get all my pieces lying flat onto two-dimensional shapes. It's a gift I wish I didn't have, okay? Yeah.
Does that ruin games for you?
It ruins everything for me. Okay, it was a great example of this. This is how my brain thinks. Okay, over Christmas, we got my son these really cool little cardboard blocks, and they're all shaped like bricks, but they're just cardboard, right? And the whole idea is stack them up, and make castles and stuff out of them. They're really cool, right? And they're all made out of cardboard. And in order to make the bricks, you have to fold them into very specific patterns to make a little brick. And at the end of the day, these bricks are really kind of neat. You can stand on them and they won't crush. Great for a 1-year-old, right? Because they're like a hurricane of destruction. If you've ever been around small children, they really are. So it's good that they're very difficult to destroy. But I was folding these and I was like, this is exactly how I'd make a 3D model of this. That's what I was thinking as I was putting these bricks together. I was like, this is precisely the exact same pattern that I would employ if I was making a 3D model of this. And I saw everything in UVs and I was like, oh yeah, they should have cut the corners a little bit differently on this one particular style block to make it fold better, to make it, my brain is cursed with this now, okay? But we need to be okay with the idea of redoing these UVs 8 or 9 times as we explore how the tools are going to generate the UVs for us, okay? One other thing to point out is that you're never, ever, ever going to unwrap the entire thing in one fell swoop, okay? Notice that I did the top separately from the rest of the top and the bottom separately from the rest of the mesh, right? I didn't try to make it all one piece. It is a fool's errand to think that you're going to be able to make this in one piece. Just let me get it out there. You can't do it, okay? You can't do it. It's a process that we have to go through, okay? Be open to the idea of exploring how the tools are making the UVs for your wine barrel, okay? Let's go ahead and explore how we're going to make the UVs for this wine barrel. Now, so let's just go through the natural thought process here. We have a cylindrical shape. What would happen if we did like the UV projection tool? I'll change my projection type to cylindrical along the y-axis, and that's what we get. Oops, excuse me, don't know what I just pressed. Drop the tool, and this is what the computer automatically generated for me. Now, is this a usable UV map? Well, the first question you used to say is, I don't know, let's test it, right? Let's put that checker pattern on it and see what it looks like with an image wrapped on there. You only ever really know how an image is going to work until you put an image on there, okay? That checker pattern that we were working with earlier is the best way to do that. So let me just put this in a material. And I always just call them test. You'll see me doing this 1,000 times. Whenever you see something that's called test, that's a checker for me. And I'm just going to use the preset since it's on my machine. Oops. Apparently I lack the ability to click on things. There we go. Let's go in. All right. Little Wacom tablet. You're screwing with me now, and I don't like that. There we go. Let's go into the actual image itself and point the... Here it is. Okay. So it's not horrible, right? Not horrible. Things are looking okay for the most part. However, what's my big issue here? Look critically at how the texture is being wrapped onto a model. What's uneven? Yeah, the cubes are all stretched out, right? If you look at the way the texture is being wrapped onto the model, it's all stretched out. I should be seeing perfect little cubes show up across the entirety of my mesh. I'm not seeing that right now. That's an issue for me. That's a big issue for me, okay? So I got to edit my UVs to get what I'm after. In addition, let's look at the UVs specifically and kind of decode what's going on. This really doesn't look uniform, does it? No, it's got some big issues. Specifically, if you look up here at the top, we have some polygons that are overlapping. What in the world is that? It's like the smallest, whoa, wait a minute. It's the UV that was made automatically for that top kind of like rim polygon is really stupid thin in comparison to all the others. That's a problem for me, right? Because the 2D version of my polygons should match the exact same size, scale, and proportions of their 3D counterpart. They need to be the same, okay? Or as close to the same as we can make them. So this isn't cool, right? This is a failure. The tools have given me an inconsistent result. Okay, and look at the seam. It's kind of wavy. Okay. Yeah, look at that. That's just kind of bonkers. That's really bonkers. And it doesn't even fit within inside of my UV quadrant. What if I force it to go in there? It's going to look even worse now. Yeah, look at that. Okay. My UV island has to fit within that upper right-hand quadrant. When I force it to fit, look at the seam. It looks like a jigsaw puzzle. I mean, it's all messed up. Bad. Part of the process, though, right? Process of exploration. The UV projection tool didn't give us the results that we want, okay? Now, let's go down the list of tools here. If we used project from view, would this work? How would we make project from view work? You really couldn't, right?
You'd have to like move to everything.
Yeah, that's no fun. We're not doing that. No, That's a monumental waste of my time, and I'm never going to get a good result. Okay? Thus enter the role of UV unwrap, or the unwrap tool. I like the unwrap tool. It's my go-to guy. Now the unwrap tool, let's just get rid of this abomination. That's just horrible. Bye-bye. Delete UVs. Okay. The unwrap tool works on a slightly different principle. With the UV projection tool and project from view, you are selecting polygons, right? You select polygons and then you do its thing. We're not doing that here with the UV unwrap tool. We are selecting edges. Now, this is where it gets a little conceptual and kind of funky and kind of weird. So hang with me here for a second. So if you're working on your homework, just pause for a second as we discuss how the UV unwrap tool works. Okay? The UV unwrap tool requires us to select edges. The edges that we select are going to determine how our UVs are made. So which edges do we select? Good question. Okay, we have to select the edges. Well, I know from experience what edges to select, You're going to have to experiment with it. But here's the overarching principle that should guide you down your decision-making process. Imagine that the edges that we select are kind of like a surgeon's scalpel. Okay? That's the part of the mesh that's going to get cut. Okay? So if we're holding our little wine barrel in a hand, we're going to cut the wine barrel like we're dissecting it down the back. And then we're going to very carefully have this really gross moment where we take that object and we just kind of bend and push and pull it and try to make it flat. Okay? Did you guys ever see the movie Face Off? Yeah. John Travolta, yeah. Right, exactly. Aaron's got it. Yeah, exactly. John Travolta, Nicolas Cage. This is before they got old and kind of useless. Okay? They were actually really fun, entertaining actors for a period of time. Not so much anymore, right? 2 words, case in point, Ghost Rider. What? What? Yeah. Oh, thank you. Yes, that should be a Ghost Rider 2. What? No. Horrible. Okay. So in Face Off, you know, they were changing faces, right? We're doing the exact same thing. So imagine I have to take a scalpel and cut like the back of my head, like all the way down here to my forehead, and then I gotta like cut behind the ears, and then I want to grab the back of my head and slowly pull the skin off of my face and try to lie it flat on the ground. I know, gross example for a Tuesday afternoon. But that's kind of what we're doing, okay? The edges that we select represent the areas on the mesh the computer is going to cut to try to lie these polygons down flat, okay? Where we select on the mesh is also going to represent the location of a seam. So we have to be very careful as to which areas we select on our mesh. I'm going to select the edge loops that are on the back. That way, you know, we're never, ever going to avoid seams within the texture, okay? But we can hide them. We can mask them. We can put these seams on the areas that we don't think our audiences are going to see them. On the bottoms, good, because how often do people look at the bottom of computer game objects? Very little, okay? And on the backs of things. Those are great places to hide seams. I've selected the backmost edge, vertical edge loop on my barrel. And I want to use that as the starting point for my edge selection. I also know that Modo likes, if you have any openings, as I do, Modo really likes it if you select the openings. We're basically creating a small little bounding box, if you will, as to where the algorithm is going to be applied. All right, so there it is. There's the edge selection that I'm going to start with. And now I can fire off the tool, the unwrap tool. I'm going to turn it on, and unlike the other two tools, the UV unwrap tool requires us to left-click and drag in the grid area over in here. Okay, we're not clicking over here anymore. We're clicking in the grid area, and we're going to left-click and drag. So I'm going to left-click, get my initial projection, and then I'm going to drag. And let me actually put my iterations down to 0. There it is. There's the initial left-click, and then I'm going to drag. And I'm going to keep dragging some more, and then I'm going to keep dragging some more. And I'll keep dragging some more until it doesn't move anymore. Ta-da! There's our UVs. We're getting closer to what they should look like. Okay, let's drop the tool. Oh, one other thing. This is something that you might want to play around with. There is an initial projection type, and this does at times have an impact on the final quality. Let's do cylindrical along the Y and see what we get. Yeah, it's almost the exact same result. Almost the exact same result. It's just twisted a little bit differently. All right, so we're getting closer and closer and closer to our final result. It's kind of off axis, you know. All of the rows of cubes on the texture are moving diagonally. So how are we going to fix this? Yeah, we're going to rotate what? The UVs. You got it. Once I start rotating and working with the UVs, what we get over here is going to change. So let me just kind of, I hate to say this, but eyeball it. There we go. And it's not a very good job, but we're on our way. Believe it or not, this is a good first step. However, this thing, not exactly what we want. Not at all what we want. Because this doesn't look anything like the example that I showed you earlier, right? That was all perfectly flat and straight and just looking really beautiful. Welcome to phase 3 of UV mapping. We make something, then we're going to have to fix it. Okay. Unfortunately, the UV mapping tools are not magical. We're going to have to edit our UVs to get the results that we want. And this, you're going to spend more time editing UVs than you would like. I spend more time editing UVs than I would like, and I know what I'm doing. Okay? It's part of the process, though. You can't avoid it, so just kind of get happy with the idea of editing UVs. Okay? Because the more accurate our UVs are, the better our texture is going to be, so there's always a direct benefit of editing our UVs. In the professional world, if you handed me this, I would hand it back to you, okay, and say, no, go fix it, okay, go fix it.
Yeah.
Go fix it. Yeah, go fix it. Okay, this is not professional. This is not up to the standard of our industry, so we got to fix it. Luckily for us, Moto has some really cool tools that will help us fix it. There's one that I want to draw focus to today called UV Relax. It's a great tool. It is seemingly magical. It's kind of like an iron. It's going to iron out our mesh at times to give us the result that we want. Let's just do it real fast. Notice that I selected it. You can find UV Relax right there, UV Relax. And like UV Unwrap, it requires us to left click and drag in the viewport. And you can see that everything's kind of moving around. It's ironing out, ironing out. Hey, that's not so bad. Now some of those big waves in the edge segment are gone. And things are looking a little bit more uniform, right? Starting to. Let's drop the tool and orient some of our, I'm going to go in and just rotate this again. Let's look at the result. We're getting there. We're getting there. The seam looks horrible though, right? That seam is this edge right in here. All of these guys. That seam right there. Okay. So we got to fix that. We got to fix that seam. We can't have it bowing on the sides like that, because that's how our texture is going to look if we were to wrap this right now with some like wood planks. Here's the next part of the UV mapping discussion that we have to consider as we go through this process, which is why it makes it so difficult. We have to think, how is the texture, how are we going to make a texture that's going to be placed on this object? Now, what texture is this going to look like? Wood. It's going to be a whole bunch of wood planks, right? Because if you look at a wine barrel, it's a whole bunch of individual boards that have been, kind of bowed to kind of create the shape. And they got some big metal straps that kind of hug those wood boards to keep them all in alignment with each other, right? Say again? They're all vertical. They're all up and down. Yeah, exactly. And they're perfectly vertical. How are you going to make a texture for that? That's a lot of work, man. That's a lot of work. It's true it would be easier if the coloring book that we made was perfect first, right? I don't want to curve. I'm going to have 40 or 50 separate little wood plank layers over in Photoshop. I don't want to have to curve them, because what if I'm off? What if I'm off just by a little bit? I'm not going to get the illusion that I'm after, right? So we have to think 8 or 9 steps ahead when we're UV mapping. How are we physically going to make the texture that's going to go on this object? Okay. Kind of makes sense so far? So how are we going to change the UVs to get the result that we want? This is the part of the process where I tell people, go find a pair of headphones, open up Pandora Man, and just zone out. Because this next bit is monkey work. It really, really is. There's no easy way around it. This is monkey work, okay? But it's required monkey work to get the result that we're after, okay? So here's what we got to do. I got to flatten it all out. Because remember, look at the example that we're after here, okay? This is what we're going for, okay? Perfect grid, woo, okay? This is what we are after in every sense. We're going for a perfect grid. Perfectly vertical, perfectly horizontal. That way, when I texture map all of those little wood planks on there, in Photoshop, they're all perfectly vertical. I don't have to think about distorting them to make them work correctly on side of our wine barrel, okay? So how do we get them like this? Let me show you. It's easy, but it is repetitive, okay? Because it requires us to basically go in and touch every single edge loop in this object. Let's just do it real fast. You got to start with one edge or one side. I'm going to start this way, And I'm just going to, oh, you can also select it here. Let's do that. Sometimes it's easier. Come on, fingers. There we go. All right. Now, when I selected that edge loop on my model, check it out. 2 different edge spans were automatically selected in my UV island. Why? Yeah, it's the exact same edge, okay? Just on 2 different polygons. Remember, we have taken my little cylindrical wine barrel and I have spread it flat, okay? The 2 edge spans that I have selected are the exact same edge on 2 different polygons, okay? You got to be careful with this, okay? I'm going to deselect one. I'm going to hold down the control key and just deselect all of those guys. And I shouldn't be doing this with my little Wacom tablet. I almost always do this with a mouse. I never do this bit with a Wacom tablet because you get the precision that you need with a mouse. This is precision type work. So let me just grab or deselect these small little spans in here. These little guys. Yeah, there we go. Okay. And now I can start aligning them. These big arrows over here are the alignment tools. These are going to automatically align all the vertices along this selected edge span and move them to the leftmost point, in my case, okay, or whatever arrow we select, okay. I'm going to select the left one. Okay, I'm going to select that big left arrow, and watch what happens to my edge span here. Yook. Pretty cool, huh? Pretty cool. And now I can just double-click and left. Double-click, left. Now all of them are basically going to go to the left until you hit that middle line, which is the next one. This one should be perfectly straight, and then once we hit the middle line for our model, we start going to the right. If you do this, you're going to maintain the proportions of all the polygons. The up arrow is your friend. There we go. All right. Already looking better, right? Already looking better. But we have some more work to do. Once we do the vertical ones, we have to go in and do the horizontal ones too. Okay? So nothing's left behind. Up arrow, yeah. And this is why turning Pandora's on is kind of fun. Because you physically have to go into every single one and fix it. Welcome to professional 3D modeling. I know it seems impossible, but it's really not that bad. Does it take 5 minutes? Yeah. It takes 5 minutes. It's not really that huge commitment of time. I've seen people try to find creative ways to avoid this, and they spend more time trying to find a way to avoid it than if they actually just did it. Okay? And then once you get down to the middle line, you start aligning it down. So just do it. See, it has taken me all of about 2 minutes to do this. Not too bad.
Is there a keyboard shortcut?
Nope. Nope. Just do it. And unfortunately, there's not. You can make your own keyboard shortcut. You can customize the application. But there's not an assigned keyboard shortcut for that button. That would be nice. Maybe in a couple weeks when we're a little bit more comfortable with this, I can show you how to make your own keyboard shortcuts. Okay, there it is. Hey, and now look at my barrel. Things are looking awesome. All the squares are uniform. There's a little bit of distortion. Some are a little stretched out than others, but for the most part, it's where I want it to be. Okay, that's a usable UV island in the texturing stage. Okay. Questions? No, everyone's good. This is what you're gonna have to go through for your wine barrel this week.
Would you UV map before subdividing? How would that affect texture?
Yeah, so we're not going to be using any subdivision surfaces in here. Subdivs are not supported by game engines, so nothing's going to hit the tab key, which is kind of a blessing and a curse. So it's good because now we don't have to super up-res our meshes to get everything to hold correctly when we hit the tab key. But, you know, we're going to see faceted faces now. You know, that's kind of the nice thing.
How would that apply to
Yeah, so same thing. No. So if you're committing yourself to a feature film pipeline, hit the tab key, check it out. Nothing really changes. It's going to change a little bit, but not extraordinarily. I would recommend always doing the UV mapping unsubdivided. It's a whole lot easier to select edges and to see exactly what's happening in conjunction with the tools. That's what I did on my Jeep. That's what I've done on basically every, I'd say my strong suit is subdivision surface modeling, and everything is UV. It's the exact same pipeline. All right, questions? Hit the U key to unhide everything. Yeah, oops, looks like these two guys didn't get the same material, but that's okay. All right, last but not least, let's talk about, let's talk about these little rivets. Rivet. These little rivets that go up and down. Now, this is a detail that I added. You certainly don't have to add this detail, but it gives us an opportunity to talk about overlapping UVs, okay? All the rivets are identical, by the way, okay? So we could use the exact same series of tools to get us the result that we want. Yeah?
So if they are going to have the exact same texture, would that be the case where you want them overlapping on the UVs?
Yes, absolutely. Absolutely. Okay?
Map the texture in both places.
Yeah, because if they're all overlapping, anything that we put in that area of our texture map is going to be applied to every single rivet on the scene. More on that next week. Okay, more on that next week. Let me show you the final result again, just so you have a point of reference as to what I'm talking about. All of these guys, let me unhide it. Okay, so those are every single bolt. They're all right on top of each other. So when I go to paint my texture map, I paint just in that area, and all of the rivets are going to adopt that exact same texture information. More on that next week, though, as we explore the conclusion of our process here. Okay. Questions? All right, let's go back and revisit what we're going to be doing for our homework and our lab assignment this week. I think I've melted your brains enough. UV mapping is a heavy thing. It really is. It's something. This is a drum that we're going to beat every week going forward. It will get easier, so just trust me on that. Okay. So as I mentioned at the beginning of class today, you're going to be making a wine barrel. And as I look around the class, I can see that a number of you guys are practically finished with your wine barrel because it's not that difficult of a model. The UV maps are going to be the really big challenging element for this project going forward. Okay. A couple of requirements that you're going to need to have for your assignment. Okay, you're going to have to make just the geometry for the wine barrel. Okay, in addition, you're also going to be making a small little scene, a little set for your guys to chill in. Okay, here's some examples of some finished projects, and you can see that the little scene that you're going to create, very, very simple. Ideally, everything that we make in this class should be generated for your portfolio. Okay, and good portfolio images provide context to the object within the picture, right? If it was just a wine barrel floating in an empty gray environment, it would be meaningless. But the moment you put it in, some sort of alleyway or a wine cellar, now you can start to understand that it's a wine barrel, right? You understand the size, the scale, the linear and spatial relationships between this wine barrel and the rest of the scene. That's an important element visually that makes it the final render more strong. Okay. So you're going to have to make a simple little scene. And when I mean simple. It's just got to be there, okay? If you look back at some of the other examples, this is just a plane with a texture on it. That's all it is. Nothing too fancy in this. Make it simple. In addition, you're also going to have to UV map both your wine barrel and your simple scene. Everything going forward gets a UV map, okay? It's a UV map. Now, I've shown you some final renders here. There's no expectation in this phase of your homework assignment to conclude it by going on and generating the textures. That's going to happen next week. We're going to spend the entirety of our time next week talking about how to incorporate Photoshop into our production pipeline to generate the final result. Okay? So we're going to set the foundation this week, and then we'll finish it up next week. All right. However, you are going to be asked to make a render of your scene, of your wine barrels, and of your little scene that it's in. So please note that I'm going to require you to make a render, 1280 by 720. The image that you're going to save and upload to the Dropbox is going to be a JPEG. Get used to doing this every single week, starting today. You're going to be generating 2 different things per assignment: Luxology project file and a render. Okay? Yes, sir.
Are renders allowed to be PNGs instead of JPEGs?
I would like them to be JPEGs.
Okay.
Please make them JPEGs. A JPEG for me, it can be a PNG for you if you'd like. But for me, just make whatever goes in the Dropbox is going to be a JPEG. Okay? When you're all finished with this assignment, please notice that I've given you guys the naming conventions that I would like you to adopt for this project. Okay? So it's last name, GCOM 424, wine barrel UV on both the LXO and on the JPEG. That will help both you and me parse all this information as we manage your media over the next 14 weeks. Yes, sir.
Did you say that we're not using subdivision services?
No subdivs. So no tab key. No tab key. Oh, yeah. In the game world, it's not about the geometry. It's all about the textures, okay? All the fine resolution, all that fine detail comes from the textures, not the geometry. Yes, sir?
Do you have a target poly area for us to go for?
Not for this one. Not for this one. Don't go crazy with it. You know, you could do this assignment on a 12, 14, or 16-sided cylinder. I think I personally would probably go with 12. Elijah?
If I was to redo my dice, how would I get like the nice round edges?
Edge bevel. Yeah, edge bevel. So let me show you what I'm talking about. Edge bevel is pretty great. Okay. So here's all the edges selected on my cube. I can just run the bevel. Oops. Let me change this to round. There we go. Now we can start getting some nice little radii. Increasing the round level on your edge bevel will increase the quality of that radius. Yeah. You can. There's this thing called profiles inside of Modo that will allow you to do something very similar to that. For example, if I just bevel this in and let's do this. This is really, oops, excuse me. Let me figure out what I'm doing here. Sorry, folks. There we go. Okay, so if I wanted to like make some molding or something, like a picture frame, I could grab those 4 polygons, bevel it out. Once I activate the bevel tool, our profiles right here will allow me to change the shape and create some really cool effects. Yeah, it's pretty neat. The profile system is pretty fantastic. So yeah. All right, let's go back to our homework assignment real fast. So that's what you're going to be doing for your homework. Just the geometry, just the UVs. That's all I want you to focus on this week, okay? That's all I want you to focus on. To get you into the habit of making UV maps, I produced a small, simple little lab assignment that will get you up and going with making UV maps, okay? In the lab section of this week's assignment, or this week's stuff, I've given you this little scene file that contains a cube, a sphere, and a cylinder. Your mission is to generate UV maps for all three of these separate items, okay? And then to apply that rainbow checker pattern to all 3 of them using the correct corresponding UV map, and then take a picture of it, make it rendered. Not too dissimilar from what you see in the supplied example. When you're done, as always, I need that render, and I also need that that LXO file. Please make sure you change the name of that LXO file to match the naming conventions that I've given you, okay? Because I believe when you download the LXO, it's just like UV Lab. What's it called? You guys have downloaded it. Yeah, so make sure you put your name on it, okay? Make sure you put your name on it. Questions? You should be able to bust out the lab assignment in the next half hour. Class goes till 4:45. And then you might be able to get a head start on your homework if you haven't already. Yes, sir? Can you make a what? Sure. Be creative. Absolutely. I think that's fine. Questions, questions, questions on both the homework and the lab assignment this week? Yes, sir.
I have Moto at home now. Can I do the lab at home?
You could, but why not do it here? You've already planning on being here. All right, let's get to work.